Alan, you need a clicker. Did not work. This one works now.
This button needs to go to the next one,
Okay.
and the other needs to go back.
Yeah, it works now. Good morning, everyone. Okay, can we close the door in the back, please? Thank you, Emmanuel. All right, good morning, everyone. Welcome again. So today we have day 2 for the stage 1 workshop on IMT2030 use cases. And the session 3 today, the theme of it is building the global 6G view. And what we're gonna have is we have 6 esteemed presenters and speakers today. So first we have Dr. Satoshi Konishi as a leader of Vision Working Group in B5G Promotion Consortium from Japan. Dr. Namseok Ko, who's chair of Network Technology Working Group 6G Forum. And we have Ms. Ying Tu, who's Vice Chair of Standards and International Cooperation Working Group from China IMT 2030 6G Promotion Group. And we have Mr. Rajesh Kumar Patak, who will be delivering his keynote remotely because due to last minute visa issue, unfortunately, he could not be here in person. And then we have Dr. Amitava Ghosh, who is the chair of National 6G Roadmap Working Group at NextG Alliance. Last but not least, we have Dr. Gustav Wilkstrom, who is a Hexa X2 and 6 GIA member and part of SNS group. So let's start the session. Let me then let me start by welcoming Dr. Satoshi Konishi, please. So Dr. Satoshi is leading the B5G. Please come here. He's leading B5G 6G, head of advanced technology laboratory in. Oops. This is for you. Excuse me, Dr. Satoshi Konishi is leading the B5G 6G as a head of advanced technology laboratories of KDDI Research Incorporation, as well as he is a senior director in KDDI Corporation. He also serves as a leader of Vision Working Group in Beyond 5G Promotion Consortium, Japan, as well as several committee members in Ministry of Internal Affairs and Communications, Japan. Very much welcome, Satoshi. The floor is all yours. Thank you.
Thank you, Puneet, for your kind introduction. My name is Satoshi Konishi. I'm very pleased to be here to introduce the contents of Beyond 5G Promotion Consortium, especially use cases that we have been provided from our white papers of Beyond 5G Promotion Consortium. Again, my name is Satoshi Konishi. I'm working with KDDI as well as the Vision Working Group of Beyond 5G Promotion Consortium. So here's the contents of my presentation today. Let me firstly introduce Beyond 5G promotion strategy in Japan, as well as the introduction of Beyond 5G Promotion Consortium. After the touching a little bit about the existing issues in Japan, because the existing issues are kind of backgrounds why we have such kind of strategy, as well as the use cases come up from various kinds of industries in Japan. The second one is that introduction of Beyond 5G white paper subcommittee, as well as the contributions to the ITUR, Working Party 5T. The third one is the main topic for today, use cases from various kinds of industries due to the limitation of my presentation time, I would like to pick up several industries to share with you. Before concluding my talk, I'd like to share a little bit about lessons learned of 5G standardizations as well as commercializations in Japan. Okay, let me start with this part. But before going to details, I'd like to a little bit touch upon the meaning of beyond 5G, because some people ask me that what is the meaning of beyond 5G? So beyond 5G actually covers after 5G launch, which means that which covers not only 5G advanced, but also 6G, maybe 6G beyond or something. So the reason why we say beyond 5G rather than 6G is that we don't know what kind of technologies and capabilities will be available to cover or realize use cases. Okay, all right, let me share some issues in Japan. The first one is that low birth rate and aging population in Japan. So let me give you some numbers from now on. Well, the birth rate in Japan right now is 1.2, and the average number in the world is 2.2. The 2.2 was realized in Japan 50 years ago, 50 years ago. And the average lifespan in Japan is roughly say 85 years old. And in 50 years ago, we had the number of 75 years old. So that means that, well, needless to say, the aging society is increasing little by little. And the total number of new babies born in Japan decreased to 1/3 compared to 50 years ago. And well, 30% of population, Japanese population, is more than 65 years old. So, well, I don't want to repeat this, but an aging society is, well, real problems, issues in Japan. And this happens especially in local regions because younger generations want to move to major cities like Tokyo, Osaka, and so on. So, well, you need to think about local regions, especially in terms of economic growth. The third one is that the natural disasters. Well, as you may know, Japan is well known that, well, we have a lot of earthquakes. Maybe one of the biggest number of earthquakes in the world. And on top of that, well, recently we have bigger typhoons as well as deadly floods. That happens everywhere in the world, I guess. This is the last but not least. Well, Japan economy doesn't grow so much compared to 20 years ago. Well, let me give you a number again here. I personally don't think that GDP is the only metric to measure people's happiness, but it's a very well-known metric to understand the strength of economy. So the current GDP of Japan is ranked as number 4th. It has fallen from 3rd place to 4th recently. And the GDP per capita is ranked as 38th in the world. And in the past, actually, Japan is ranked 2nd in terms of both GDP and the GDP per capita. So these are major issues, but there are other issues as well. So this is the background of why we have to promote further communication technologies like beyond 5G and 5G or 6G. Well, Japan, most of the Japanese operators like NTT Docomo, KDDI, and SoftBank launched 5G in March 2020. Right after the launch, we faced COVID-19 pandemic, as you know. So we realized that, or recognized that very importance of communication technologies, not only by us, but also customers. And at the same time, we think that the facilitation of CPS, cyber physical space, is also very important by using a lot of big data. So this is one of the trigger to think about beyond 5G strategy in Japan. And as you can see, this graph or slide, well, beyond 5G is regarded as two parts. One is that the evolution of its existing 5G strategy, EMBB, URLC, and MAS MTC. On top of that, we have to tackle with various issues as discussed yesterday. One of the things is that the low power consumption. The other one is that the security and the resiliency issues. And in addition to them, autonomous network as well as the scalability are also very important to realize new features as well as the enrich our society and lives. Well, in order to promote this strategy made by Japan's government, we established a new Society Beyond 5G Promotion Consortium in December 2020, and by the collaboration among three parts: industry, academia, and government. As you can see in this slide, there are two main committees. One is that committee for planning and strategy. The other one is for international committee. The international committee is responsible to enrich the collaboration of various kinds of organizations, including 3GPP and other standardization bodies, as well as the consortium forums and so on. The other one is the planning and strategy. And as you can see, there are three subcommittees under the two committees. And one of them is so-called white paper subcommittee. That is what I'm going to tell you from now on in detail. Well, before going to detailed explanation of white papers as well as the use cases, I'd like to make a small announcement to you. Well, in fact, Beyond 5G Promotion Consortium was merged with the 5G Mobile Forum by the end of March this year. And from this April, a new organization named XG Mobile Promotion Forum, XGMF, was established. Well, we have been considering the details such as organizations, leaderships, objectives, outcomes, and so on. So what I can say right now is that the XG Mobile Forum is going to continue to promote international collaborations, as well as this, studying technologies and use cases and so on. Okay, let me go on to the next topic, contributions and activities of Beyond 5G white paper subcommittee. Well, this is the structure of subcommittee named white paper subcommittee. And this is led by Takehiro Nakamura of NTT Docomo. And under this subcommittee, there are four working groups, one of which is named the Vision Working Group, which is led by me, as well as Satoshi Nagata of NTT Docomo. So Vision Working Group is responsible for studying use cases as well as the requirements toward the Beyond 5G or 6G era. So we actually published a variety of contents as a form of white paper from 2 years ago. The first release was version 0.5, and the contents was immediately form of contribution to ITUR Working Party 5D, and right after we release or revision of white papers, we submit contributions as a member of Japan to ITU Working Party 5D. And as you know, the recommendation IMT2030 was released or adopted at the end of December last year. So one of the contributions what we done is that usage scenario as well as the symbolic figure of IMT2030. So this figure is a proposal from Japan as well as the Beyond 5G PC. Well, as you know, the wheel diagram like this is very close to our proposal because, well, one of the things is that IMT 2030 is an evolution of IMT 2020, and well, new IMT 2030 has a form of hexagon, and there are 6 vertices and 6 use cases. And the contents of the usage scenarios are almost the same as the IMT framework or recommendation M.2060. So most of the parts are adopted in M.2060. Okay. All right, let me move on the details of the outline of white paper. Well, this is the structure of our white paper. Due to the limitation of my presentation time, I cannot explain details because it contains more than 300 pages. But the main parts for today is chapters 4 and 5 because it includes use cases as well as requirements from various kinds of industries. And KPIs are also summarized in the chapter 5. From the beginning, we imagined that we better to capture or collect a lot of comments from various industries. So that's why we established a workshop named Workshop of Society in 2030s. And we actually invited various kinds of industries and companies from bigger one to, well, startups. Well, one of the big companies is Toyota Motors, and well, other big companies are also invited to make the speech and exchange our opinions and comments to enrich the contents of use cases and understand what they really require to telecom industry like us. So this is the detailed contents of white paper in chapter 4 and 5. Of course, you can download the white paper using the URL. Well, as you can see, there are various, and I think all the industries are captured in this white paper. And well, again, due to the limitation of time, yes, I'd like to pick up several industries to introduce here. The first one is machinery industry. The machinery industry, well, it's a very wide and broad terminology, and where machines are used by agricultures, automotives, electronics, and so on. But what I focus on here is that industries, companies which have own factories. So actually, well, several companies are using or having factories want to replace their cables to wireless. They have been utilizing a lot of cables connected to each other among multiple machines and equipments and so on. But they also want to change their production lines so often compared to the past because market demands, customer demands are changing fast. So what they want to do is to change the production lines so quickly without losing the time and cost. So they really want to utilize wireless instead of cables. But they told me that they don't rely on wireless right now, unfortunately. So the requirements here is that one of the requirements is here is that ultra low latency. So what is the number? It's quite hard. 100 microsecond, 0.1 millisecond in end to end. So which is a very high hurdle for us. But this is a real requirement from the customers, vertical industries. The next industry I'd like to show you is that automotive. So this industry is one of the aggressive industries to utilize latest technologies like AI and communication technology and so on. But they have many visions for the future, like, well, many people like us want to move frequently and fluently without any problems with efficient manners. And they think that the collaboration between the vehicles, among vehicles, as well as the cities are also very important. Well, one of the big use cases in automotive industry is that autonomous driving, as you know. So in order to realize autonomous driving, of course, the sensing accuracy is very important using ICS in the future. And well, in addition to that, throughput as well as the low latency is also very important. So next one is the warehousing and logistics, which is very close to automotive industries in terms of using vehicles and robots. Well, this industries needs to cope with the social issue, that I said at the beginning of my presentation, like aging society in Japan, especially in the local regions. Well, due to the lack of workforces in Japan, they want to, well, change their lines as well as the way of doing working by utilizing a lot of new technologies like robots and autonomous driving technologies and so on. So, well, in addition to that, the logistics warehouses tend to be located in rural areas, local regions, rather than city areas. So the coverage area is another important issue for them. So NTN with HAPS are very important to to the industry. Requirements are also very important for in terms of latencies as well as the time synchronizations, which can be realized by using PTP, a precise time protocol. The next one is that healthcare industry, where it is another important industry for all of us, especially in Japan, because as I said, Japan is facing an aging society. So we have to care about our bodies by ourselves by asking, well, some tools or gadgets like IoT devices and sensors and so on. So there are many use cases toward beyond 5G that the industry is expecting to telecom industry. But what I want to emphasize here is that telesurgery and invasive surgeries, because especially in local regions, we tend to lose hospitals and medical care centers and so on. So it's better to do something, especially to those areas. The requirements to realize telesurgery as well as invasive surgery is like this. Well, it's very huge in the tens of gigabps in throughput, as well as very high reliability, 10 to minus 7. And many devices may be existing in a small area, especially in the congested trains, for example. The media industry, this industry has been eager to seek new use cases and immersive experiences to provide them to the customers. Well, rich contents is very important for them. So needless to say, kind of 2D image and video will be replaced by 3D video and image in the near future by using holographic technologies, as some people discussed yesterday. So according to their requirements, the number of requirements, there are a number of requirements. One of the biggest one is that the throughput, definitely. The number is hundreds of gigabps without any compression of 3D video. So from this slide, slide number 21 to 24, well, these summarize the total requirements gathering from various industries. And I don't go through details, but you can download it from white papers as well as this presentation material later on. But the point is that from a viewpoint of, well, EMBB perspective, a few hundred gigabps is required in end-to-end. The next term regarding low latency, as I said, 1 millisecond or 100 microsecond will be required in the future from the viewpoint of industries to replace the cables to wireless technologies. As for reliability, 10 to -6 or 7 will be required to realize remote surgeries and remote monitoring and so on. Positioning and sensing are also important with accuracy of 1 to 2 centimeter. And massive MTC requires 10 to 6 to 10 to 7 devices per square kilometer. The last one is that coverage area. It is also very important in Japan, especially disaster situations. Well, 100% land coverage is necessary. And in addition to that, some space industries want to introduce communication technology outer space. So this is the radar chart in terms of KPIs with comparison of 5G and beyond 5G or 6G or IMT2030. So as you can see, well, beyond 5G requirement is very hard for us, but at the same time, what I want to emphasize here is that the industries do not want to see only RAN side. So as you know, IMT2020 requirements in ITU documents mentions only RAN. But from the viewpoint of the industries, they don't care about RAN, where is RAN, where is mobile core, where is transmissions, and so on. So what they care is that end-to-end performance. That's why Beyond 5G PC mentions that E2E, which means that end-to-end rather than RAN. Well, this is the contents of expectations from multiple industries. When I listen to multiple industries requirements, I see that several requirements are common, regardless of industries. So I summarize this table in line with the existing issues in Japan, which was introduced by me at the beginning of my presentation. So first one is that the decrease of birth rate or aging society. Well, many people want to utilize robots, remote control, and so on. But then, well, high throughput as well as low latency and reliability is very important. Safe and secure in order to tackle with the natural disasters, for example. Well, our person coverage area is also very important. Well, as you may know, we had a big earthquake on January 1st, and with a magnitude level of magnitude 7.6 or 5 or something. And well, we provided satellite systems, then that helps a lot to the disaster areas or refugees of the disaster earthquake area. Regarding the toward the wonderful lives and the future lives, well, definitely we like to seek new capabilities to realize the immersive communication tools as well as use cases. Well, flying cars may be available in the near future. Then we have to provide low latency, reliable communications as well as the high throughput to see immersive videos and images. And for the future, so some of them may be having a chance of opportunity to go outer space. Then you may want to have a connection with the Earth to upload your photos or videos to the Earth. So, well, space industries want us to prepare communication infrastructure in outer space as well as in the moon, on the moon in the future. Well, before summarizing my talk, I'd like to share lessons learned about 5G standardizations as well as the commercializations. Well, there are many good aspects about 5G, actually. Well, some people say that 5G maybe in fail or something, but I don't think that because we are still on the phase of improving of 5G. Well, here's the pros and cons. Of course, everything has pros and cons, right? So let me summarize into two pros. One is that, well, we successfully define a good 5G structure in terms of usage scenarios like EMBB, URLC, and massive MTC. So that is a pretty new compared to 4G, right? And we have good idea. We had a good idea about utilizing existing mobile core of 4G EPC to enhance the coverage area as well as the enrich the throughput using ENDC, as you know. So that is very good points. But at the same time, well, there are many functions as well as capabilities. That is certainly burden for standardizations as well as the increased cost of development of new products and maybe increase the operation costs. Second one is that, well, thanks to the new capabilities of 5G, well, I think many industries really seek the opportunity to utilize 5G. And well, many people, including me, may mislead all of the world or some industries about 5G understanding. Well, they really want to have a full capability of 5G at the first launch of 5G. So there are gaps between the network, real network performance as well as the, well, their expectations. So one of the things is that KPIs, as I said earlier, is indicated only rampart, but from the viewpoint of industries, they want to seek end-to-end performance. Otherwise, they cannot design and plan their systems by themselves. The second one is that network performance were not guaranteed or were not stable at this moment. Well, as I said, some industries which use factories or own factories, they want to replace the cables to wireless technologies. But what they confessed me was that they do not rely on wireless technologies, unfortunately. But they didn't say that they don't rely on wireless engineers. So please don't worry about that. But we have to come up with some ideas to realize their expectations. So end-to-end performances as well as stable network performances are really necessary from the viewpoint of those industries. The last one is that, as I said, the triangle of 5G has not yet realized. So some industries, the companies ask me, which point of triangle you can provide all the time? But I don't think all the operators can say that right now. So it is a big gap between the vertical industries and MNOs right now. So the last, but not least, my comment is that we need to have a guaranteed network or stable or reliable network to satisfy SLA, service level agreement with customers. Okay, let me summarize my talk. Thank you for listening my talk, and I'm very happy to share the contents of Beyond 5G PC's white papers. Well, first of all, we successfully released the white papers that includes various use cases, which is very unique, I think, compared to the others. And some of them were adopted in ITU M.2160. And well, after hearing or listening to various comments or requirements from various industries, well, we see that, well, very high hurdle to realize the beyond 5G or 6G in the future, like these numbers. This is last but not least. Well, on top of this kind of challenging KPIs, we have to think about to realize end-to-end performance with guaranteed or reliable, stable networks in the future. Thank you very much for listening.
Thank you very much, Dr. Satoshi, for such an excellent presentation and sharing a very valuable insight on the work which is ongoing in Beyond 5G Promotion Consortium. So we have some time for the question and answer. So let's go from the audience. Start from the back. Prachi.
Hello. Yeah. Thank you so much for the presentation. In a lot of slides, you mentioned the coverage on the move, and I was curious to know what kind of technology are you hoping to bring there? Is there a timeline? And is this something you're doing in collaboration with JAXA?
Mm-hmm. Yeah, thank you very much. Yes, as a matter of fact, JAXA is seeking to have that kind of technologies in the near future. And I cannot say what time would be, but well, they want to seek the possibility to utilize the 5G and the cellular networks technologies because they are very cost effective and they can change the systems easily.
Thank you. Other questions? Dr. Gustav, please, in the front. Microphone here.
Yeah, thank you. You mentioned industries a lot. So you have grouped use cases according to industries. Does this mean that you focus more on business-to-business services going forward, and there's a much lower emphasis on consumer services?
Okay, thanks. Well, both actually. But main topics what I explained today was B2B to X rather than B2C. Well, except a media industry which will provide well, normal applications to customers and the customers, then that may be B2C. But well, most of the industries which really want to have 5G technologies, we want to seek the possibility of B2B rather than B2C, B2B to X.
Thank you. Other questions? We'll go from the back. Sparsh, NGMN.
Hi, Satoshi-san. Thanks for the nice presentation. So you have shown the critical KPI of 0.1 millisecond as an enterprise requirement. So do you have some stats of the really requirement in terms of scale? How many such critical KPIs are business needs at this point of time, or do we have any projection for future?
Well, thank you. That is a very good question. We haven't yet thoroughly investigated entire Japan industries and companies, unfortunately. But that is one of the requirements certainly happened from one company, one industries. So I think this is my personal guess. This may be wrong, but well, this kind of requirements may be common to the entire society.
Just a follow-up on this one. So in your study, have you ever got any such area in which you get these figures or are available in the market to really take upon these critical KPIs?
Well, of course, it depends. But well, some companies actually are willing to pay money if they can replace wired or cables to wireless, because it's very beneficial for them. Not only factories, but also other industries, as a matter of fact.
Thank you. So we have time for a couple of more questions. So Juho and then gentleman on the left after this. Juho, please, can you have from here? It would be great if you can say your name and company so that the speaker knows who to is.
Yeah, my name is Juho Lee from Samsung. It is quite good to hear from you about replacing cable. But then, as a private company, it will be interesting to understand the expectation about market size. So if you work on replacing cables for some industry, then does it give us enough kind of money to continue our job?
I really hope so. Yes.
Do you have any data? I mean,
well, unfortunately, I don't have any particular data for that. But as I said, and I answered it to the previous question. Well, there are many demands like that, and well, if we can realize that a revenue share method between the business partners and operators like us, then we can get some money from them, and then we can get the money. After that, we can well, buy more products from your side. That's a success story.
Thank you, Eric, please.
Thank you. I'm Eric Ardouin from Orange. You mentioned 100 gigabit per second for holographic communication as a requirement. I assume this is for uncompressed video. So can you clarify why not using video compression to reduce this huge data rate?
Yeah, definitely, yes. If we use compression method, then yes, the total amount of bandwidth will be reduced, certainly. But some of the companies want to utilize the 3D video without compression because the latency is more critical in the future. For example, online gaming, if they want to utilize the communication technology for online gaming with very high precise videos using 3D, for example, they don't want to utilize compression so much. That's why we said that the maximum data rate requirement for telecom industry.
Thank you. Kevin, please. Kevin Hawley.
Yes, hello, Kevin Hawley from BT. I was reading this morning that Tesla has announced that they've automated their factory in Germany using 5G, and they're planning to export that to their other factory locations. So my question is, do we need 6G for factory automation, given that it already seems to be being implemented with 5G? Is 5G not good enough?
Well, I don't know what kind of requirements Tesla has, but well, I think if 5G is well good enough, then why don't we utilize 5G? And if there's some room to improve utilizing 5G, then why don't we improve our system towards 6G? That's it.
Thank you, Giovanni.
Thank you. Giovanni Romano from Novamint. One of the problems I've seen with 5G is that the marketing and politicians were expecting to have the three points of the triangles simultaneously. So what about your expectation? You showed a spider diagram with a lot of improvement towards with respect to 5G, but do you expect to have all the improvement simultaneously, or just one to the expense of the other? For example, a very high data rate with throughput, which is with latency, which is not so good, or everything is to be obtained simultaneously?
Mhm. Well, I don't think we have to realize everything at the beginning, because it strongly depends on market demands. So if we clearly say that this demand is very important for telecom industry, then what we have to do is to realize that first. But what I want to emphasize here today is that even in the triangle or hexagon, what kind of performance we can provide to the customer. So that is very important point for both telecom industry and the customers or vertical industries, in order to have a good collaborations and have a good businesses with them.
Okay. Thank you very much, Sir Dr. Satoshi.
Yeah.
So that's all we have time,
you.
but he'll be around if you have more questions for him. So
Yes.
please approach him during the coffee break. Thank you very much.
Thank you.
Okay, so let me then invite our next speaker, Dr. Namsok Ko, who is leading the Mobile Core Network Research Sections at Electronics and Telecommunications Research Institutes, which is ETRI. He's serving as a Vice Chair of Technology Committee and a Chair of Network Technology Working Group in 6G Forum, Korea. He is also an Associate Professor at the Department of Information and Communication Engineering, University of Science and Technology, and he is also serving as a Vice Chair of SG11 and Rapporteur of Q20 of SG13 in ITUT. Welcome, Dr. Satoshi.
Thank you. Thank you. Yeah, I'm happy. Thank you for introducing me. Okay, my name is Namsok Ko. I'm wearing actually several hats, but now I'm wearing a hat. I mean, two hats here. The first one is I'm the chair of Network Technology Working Group in the 6th Forum, and the second hat is for the director of ETRI. So I'll explain the 6G Forum's view on IMT2020 use cases, but I guess because you already heard from Japan, I guess the situation is very similar. I didn't discuss this issue with Japan, but I found that it is very similar. You can find that later in the after you hear this presentation. Okay, I'll explain. Let me introduce the 6th Forum first, very briefly. 5 Forum has contributed successfully during the past 10 years since its inception on May 30, 2013, and it was reborn as a 6G Forum to secure global 6G leadership in line with the K Network 2030 strategy of Ministry of Science and ICT on May 30, 2023. It is a public-private cooperation system, and we proactively set 60 strategies in response to the rapidly changing technological advancement to secure global leadership, and we also promote international cooperation with global 560 related organizations, and also support leadership in international standardization. We also put efforts in the identification of new services to accelerate the convergence across various industries with 5G and 6G. And based on the experience and lessons learned from 5G commercialization, we want to support government research institute, academies, and industries to accelerate innovation in 6G. But we also put our effort in 5G expansion into verticals for the time being. It is also the same in many other countries. Here's the organization. Under the General Assembly, there's Executive Committee. The chair of Executive Committee is Kyung-hee Chang. And there are 9 technical committees and 9 working groups under the technical committees, and there are 2 teams. And there are 10 chair companies and 37 member companies worldwide. There are this is the activities by number. You can see we have 20 global cooperation with international organizations, and annually we are having around 110 committee or working group meetings, and we have hosted 38 global and regional events worldwide. And you can see there are many white papers and issue reports, and we also support project and policy generation in the government. Okay, I will explain the vision and use cases of 60 Forum. The ultimate vision for 60 is to advance human happiness, prosperity, and sustainability through 60 technologies. Based on the societal requirements from various fields, we can have technical support. Based on the technical support, you can have cleaner, safer society, and more sustainable society, and more transparent society. There are 3 drivers of 60 in Korea. The first and the most important one is societal requirement, as explained in the previous slide. And we also have technical advancement. The 60 is also pushed by technological advancement. And the last one is the policy lead. In Korea, we had a K Network 2030 strategy, which was set in February 2023. And based on the K Network 2030 strategy, we are pursuing 2 government-led programs. The first one is 60 Core Technology R&D program, which was started from 2021. And the recent one is 60 Commercialization Technology R&D program, which was started from this year, actually April this year. And you see these scenarios and use cases. Actually, I guess you also saw these slides a lot. We also contributed a lot to IMT2020 framework document. So we want to explain the use cases based on the usage scenarios from ITR's framework document. So I don't need to explain all the details here. So I'll explain the use cases from each usage scenarios. The first one is immersive communication, which is the extension of the EMBB for rich and interactive immersive experiences. And the capabilities required it will be enhanced spectrum efficiency, higher data rate, high reliability, and low latency. And the use cases, representative use cases will be telepresence and holographic communications, remote multisensory telepresence, hyper-realistic metaverse, remote healthcare, such as telesurgery. And the massive communication, which is the extension of the MMTC to support connectivity of huge number of devices. The required capabilities will be high connection density, low power consumption, mobility, extended coverage, and high security and reliability. The representative use cases will be massive Internet of Things related scenarios and metaverse and ubiquitous personal connectivity. And hyper reliable and low latency communication is the extension of the URLC to extend the boundary of URLC by covering more stringent requirements on reliability and latency. The capabilities required for this one will be enhanced reliability, enhanced low latency, precise positioning, and connection density. And the represented use cases will be industry and automation, healthcare, fully autonomous driving, excellent tactile internet. As I guess you also heard a lot, and those scenarios are also, as questioned a lot from yesterday. All those scenarios were also mentioned in 5G. and even for 60 they are very similar. And the ubiquitous connectivity is to enhance connectivity to bridge the digital divide. So the required capabilities will be TN and TN integration, and new spectrum and frequency band, RIS, AIML, and the representative use cases will be related to global internet connectivity and IoT networks such as smart cities, environmental monitoring, etc. And integrated AI and communication is to support distributed computing and AI, especially LLM is very hot these days. So LLM applications. And the required capabilities will be high area traffic capacity and low latency and high reliability capabilities related to the integration of AI and compute functionalities in 6G, such as the data acquisition, processing, model training and sharing, etc. The use cases related to autonomous collaboration between connected AI robots, cobots, and offloading of heavy computation operations across devices and networks, and 6C assisted automated driving. And the integrated sensing and communication is to offer new possibilities for smart applications, enabling enhanced sensing capability, enhanced efficient resource utilization. The capabilities will be sensing-enabled communications, data fusion for distributed sensing, multimodal sensing, and intelligent sensing and communication coexistence. And the use cases, as you can see on the slide. And based on the use cases explained in the previous slides, as you can see, they are very, you also heard a lot before as well. And we try to prioritize the use cases that can be realized in day one. But if you ask why did I choose or the 60 forum chose these use cases, then it could be very every person has different answers. But based on the discussion, we prioritize those use cases. Like from immersive communication, we chose hyper-realistic metaverse. From integrated sensing and communication, there will be 6C assisted navigation or environmental monitoring. And from massive communication, smart cities, transportation, agriculture, supply chain management. And from ubiquitous connectivity, NTN, and air mobility such as UAM, and IoT networks, for example, a smart city. And from hyper reliable and low latency communication, industrial control and operation, fully autonomous driving, remote telesurgery. And from integrated AI and communication, there will be autonomous collaboration between connected AI robots, and also automated driving. So even if we listed up the use cases that can be realized in day one, I guess you also ask, as I already told you, you may have some questions why did I chose these scenarios, but we don't have clear answers, and we don't have any specific KPIs for now. Even if we have discussed a lot on the KPIs for the use cases, but here we thought it was not appropriate to open the KPIs before they were clearly agreed in the forum and the members of the forum. So I didn't show up the KPIs here. And one of the regional specific use case, I think it is very similar to Japan's case. Korea has entered very rapidly into a super aging society. The elderly over 65 will be around 30%, more than 30% in 2035, and it will be more than 43% in 2050. And that is exacerbated by the persistently low birth rate, and we are lacking of caregivers. So to address this issue, we want to realize the elderly care services by combining sensing, AI, and robot mobility with communications. Some of the basic use case of elderly service, such as health and behavior monitoring, can be realized in day one maybe, but the others will be more evolved later as AI and robot mobility capabilities are more advanced. So to realize those day one use cases, we, as I explained before in the previous slide, we have started 60 government-led mega projects. So I'll explain that day one R&D in Korea. The direction for the R&D in Korea is to overcome the limitation of 5G, reflecting the future technology trends. There are multiple areas that were chosen, like advanced wireless technologies such as upper mid-band or coverage extension, and software-centric and network evolution technologies such as ORAN, cloud-native technologies, and AI-native technologies, and the technologies beyond communication such as computing and sensing integration into communications, and also energy-saving technologies and technologies for supply chain enhancements like components. And we, as I said, the project has started from this year, April this year, which is around 327 million US dollar, and it will be until 2028. There are 11 strategic technologies across 4 sectors, as you can see from this slide, from eMIMO systems to 60 systems supporting AI native application services, considering also sustainability issues like low power consumption, the security and reliability issues. This one shows the 6 spectrum that we are considering for now. We took a layered approach from low band to high band to support diverse usage scenarios. But we are also, we are focusing on upper mid band from 7 to 24 gigahertz to support coverage and extreme capacity. We proposed 3 upper mid band to WRC23, and 2 of them were adopted, like 7.125 to 8.4, and also 15.8 to 15.35, 14.8 to 15.35 gigahertz. So for the upper mid-band spectrum, we are developing extreme MIMO and coverage expansion technologies such as RIS, NCL, and advanced duplex technologies. I guess we don't need to go into too much detail on this one. And also, we are working on cloud-native core network technologies, and also AI-native WAN and core network technologies, as you can see in the slide. And for AI-related technologies, we are working on AI-based energy efficient network, such as AI-based radio resource control and optimization technologies for energy saving and radio efficiency enhancement. And this one is also very similar to Japan. We, when you see 6G, 6G is not just a radio technology, but it is also wide network has to be considered. To support ultra high speed and capacity, for example, optical transmission system and component technologies should be also supported. So we are working on this one, like optical transmission system and component technologies. And also, I mean, as explained in the previous presentation, we also have C as 6G as end-to-end technology. So when you see to guarantee the performance, it should be end-to-end performance assurance. So we are also working on the system technologies to ensure end-to-end performance assurance to support diverse 6G services, such as framework for end-to-end service performance assurance technologies and also service orchestration technologies for AI native services. So after developing these technologies, the project started from April this year, then it will be finished in 2028. But during the project period, we'll have two demonstration or vision festivals. Which one is called Pre-6G Vision Festival, and the last one is Vision Festival, 6G Vision Festival. We after developing the technologies, which will be around 47 core technologies in 11 strategic technology areas, we'll have demonstration to secure the initiative in 6G commercialization of Korea, from software centric network to expanded role of networks. And finally, we'll have Vision Fest at the end of 2028, and it will be the starting point for the deployment of 6G in Korea. So I guess, yeah, it will be the starting point of 6G commercialization. 2028 or 2030 will be the time for the commercialization in Korea. So here's the takeaway. To realize 6G vision of advancing human happiness, prosperity, and sustainability through 6G technologies, 6G Forum coordinate three drivers: societal need and technological advancement and policies in government. And we keep identifying use cases that can be applied to various industries and reflecting regional characteristics. And we will also actively pursue ongoing activities such as supporting 3GPP and ITU standardization. We believe only one single standardization is needed for 6G. So we wouldn't try to have different standardization for 6G. And also we'll try to publish technical white papers and also seeking global collaboration so that you can ensure the safe landing of 6G technologies. Okay, that's it for the presentation. Okay.
Thank you very much, Dr. Namsok. It's an excellent presentation. Okay, let's go for some questions in the room. Start from the right. Rui.
Thank you. This is Rui from Citi. So I have two questions regarding coverage or ubiquitous connectivity. In your slide, you mentioned a few technologies related to that, like WIS and also AI/ML. I think it's understood that WIS can improve coverage, but what do you have in mind for AI/ML application related to this usage scenario? This is the first question. And the second question is related to the upper mid-band coverage. You mentioned here you aim to have a coverage layer on also upper mid-band. So do you expect to have the whole range for macro coverage? Thank you.
Okay, the last one first. when you support mid-band, did you ask, I mean, using the mid-band to cover the whole macro area?
Yes, yes. Do you have this expectation?
Yeah, I guess that'll be, I mean, the coverage will be a little smaller than a mid-band, definitely, but I guess we're trying to, I mean, trying to satisfy the coverage and bandwidth. So we are focusing on the upper mid-band. So I'm
Yeah, sorry for interruption. Yeah, this is Min from SK Telecom. So we SK Telecom is also a member of so chairmanship of 60 Forum, and I was a member to planning that yes, government-driven funding. You are asking two questions. One is regarding the energy efficient solution by utilizing AI ML. So we are open to research how to deal with AI ML technology into RAN area. And one of the interesting area especially from our Prime Minister, from this Prime Minister of the Science, MIST, is the AI ML utilization by certain kind of the SOC SOC for AI SOC, and by to aiming some the energy to is the energy saving or the to increase performance. That's the number one answer. And regarding the upper middleman the coverage, so because this is not a for the certain kind of commercial planning, but to research so how to deal with the coverage and capacity by utilizing the upper midband. And I wanted to compliment one more stuff, because last December the IMT2030 decide to include one of the future IMT candidate for the from the 4.4 to 4.8. So we do not exclude that lower midband in our research topic. And again, so we do not limit some the coverage of by utilizing upper midband, but so we really look forward to come up with the that upper midband spectrum compared to the existing our the 5G NR coverage, yeah, which is mainly deployed by the 3.5 gigahertz band. That's my answer.
Thank you, Ray.
Sorry,
Follow up.
let me add.
There's some misunderstanding on
Yeah,
the question.
let me add
Actually,
the AI related one.
Yeah, AI ML applications. My question is on the ubiquitous connectivity.
Yeah,
we can take it offline.
Yes. Okay. I mean, there is AI related optimization can also help to enhance the radio, so which can help the coverage extension as well. So that is the point, I guess.
Okay, maybe if you need more, you can follow up during the coffee break. Let's see other questions in the room. Giovanni, and then we'll go to Rishikesh.
Thank you. Giovanni Romano from Novamint. Two questions really. The first one is yesterday from Verticas, we heard a lot about life cycle of devices for Verticas, which is much longer than 3GPP release or something like that. So in your activity, are you taking into account this kind of legacy with devices which have a much longer life cycle than smartphones? So for example, how to manage IoT devices that could have a much longer lifespan than smartphones and so on. The second question is more on impact on 3GPP, and maybe it's for all the speakers. Since there are a lot of new, very challenging requirements, do you expect that this is impacting the activity in 3GPP, so the capacity to deliver specification, good specification to have a commercial solution by 2028, as you mentioned before? Thank you.
Thank you very much. And the first question is about the lifetime of the previous generation of mobile technologies, right? So I guess it will be very difficult. I mean, as discussed yesterday, even 2G is still being used in many places. So I guess it won't be easy to phase out the previous technologies very easily. So I guess yeah, it's not that deep, I mean, easy to answer them now. But I guess I mean, regarding this one, I want to mention about I mean voice of 6G. So when you think about like new capabilities like voice over 6G, we have to think about phasing out of the previous generations. So if you don't support like voice of I mean 6G from the day one, I guess we have to have the previous generations all the time when you deploy when you want to deploy 6G. So we have to consider, we have to take into account that kind of I mean approach when you deploy new technologies. So I'm not sure if you get if it is the answer for you for the first question. Okay.
All right. Yeah, partially yes. I was also thinking about what yesterday was mentioned as backward compatibility. So the possibility for devices of previous generation to work in a 6G network or vice versa. But okay, you mostly answered my question. Thank you.
Thank you. Other question in the room? Rishikesh, in the back, please.
So Rishikesh Chakraborty from Vodafone. I'm going to stick with the theme of asking two questions as well. So question number one refers to the spectrum where you identified the 7 to 24 gigahertz band as potential candidate for 6G spectrum. And we talked about whether it is suitable to deliver macro level coverage. That's still an open question, it seems, and there are doubts as to whether that can be delivered. But more importantly, if those bands turn out to be congested and don't become readily available for 6G use, then is there an alternative spectrum plan that your consortium is considering? That's the first question. And the second question is, I think a lot of us will agree that we should connect the unconnected and seek to bridge the digital divide, to quote from your slide. But a lot of that might be delivered by just delivering cheaper handsets using 20 megahertz bandwidth, for which LTE seems more than sufficient. So is that really a 6G technology priority, or can that be delivered with existing technologies? Thank you.
Thank you very much. And the first question is, as I mentioned, the 6G spectrum wise, it is a layered approach. So we are not saying one, I mean, specific bandwidth is the old technology that we are pursuing. So for the midband and low midband, we are also proposing the spectrum for 6G. So I guess as you worried, maybe upper midband won't be available for the macro coverage. So in the case, we are also thinking about other bands as well. And about the second question, I mean, I guess the point is a little different. I mean, when you think about ubiquitous connectivity, I mean, as you said, maybe cheaper the smartphone smart devices will be enough to support unconnected in some areas, like I mean in the city areas. Still, there are many people who are not using smartphones, and maybe cheaper one can be the solution to bridge the digital divide. But in many other places, like in the rural areas or other areas which are not supporting the mobile infrastructure, then in the case we need the technologies like NTN or other technologies. Is that enough?
Thanks.
Okay, thank you very much.
All right, thank you. Other questions? And maybe we stick with one question. Scott.
Thanks. Building just a little bit on the question that you answered for Giovanni, you were talking about having to bring forward all of these 5G capabilities and services into 6G. I fully agree. By the way, I'm wondering though, we are encumbered by some of our even older Gs still to this day in the network. So kind of changing the theme from talking about the fun radio stuff. Looking at our network, we're stuck with IMS, a 3G technology that's primarily just used for a lot of voice stuff that we could be doing more natively on the 5G core or beyond. Do you think 6G might be the time we start to look at how we can pull the last remaining functionality out of IMS and remove that from our architecture and incorporate that into the core itself?
Thank you very much. I guess it is not. I have to express from my personal opinion, because it is not agreed in the 60 forum. So from my personal perspective, I believe we need to we need to support those kind of new technologies into the 6G mobile network. I want that kind of change in 6G. That's my personal opinion. It is not from 6 forums view. Is that enough for your question?
I believe so. I mean, what Scott is basically asking is, can 6G deliver non-IMS based voice, right? So, okay, I think maybe we discuss this in 3GPP. All right, so the question, I think the gentleman there, please. I don't know your name.
Thanks, Luca Viasat. So my question was, you mentioned advanced duplexing. There's some work right now on subband full duplex, subband half duplex. Where do you see this going?
Actually, I'm not an expert in the physical layers, so it's not appropriate to answer your question for now. If you can have a talk later, then you can solve the issue.
Thank you. So, gentleman in the middle, please.
Yeah, this is Wayman from Future Wave. I have a question on the millimeter wave. We know a millimeter wave is not a big success in 5G, but it will be valuable to actually still make use of it, especially in 6G, make it more reliable and useful. What is your plan for that? From our perspective, just continue doing the same approach in 5G may not be very helpful for using millimeter wave.
So in Korea, recently, new service provider was allowed. They are planning to use a millimeter wave for their service. So I guess still for 5G, they're using 5G technology to support millimeter wave to 28 gigahertz millimeter wave. So they will be used in a small area like stadium and the area where people gather very quickly in those areas. So they are targeting the specific services for specific people to use millimeter wave. And I guess it'll be the same in the 6G. I think we can also, that is my personal opinion as well. We may still use millimeter wave for 6G, and definitely there'll be some target services for specific cases. And as you can see in this slide, as I already told you, there'll be a layered approach. So millimeter wave or sub-terahertz can be more useful for sensing or ultra capacity in some specific use cases.
Thank you. Ma'am in the front, are you recording here? So may I request you not to redo the recording? Taking pictures is absolutely fine. Okay, so please do not have recording. Yes, ma'am in the back.
Thank you for the presentation. My name is Lola Awuni-Terry from Qualcomm. I have a quick question about your day one slide. Looking at the ITUR 6 usage scenarios, I think you have use cases that you think in day one will be able to support. The question I have here is it really realistic that on day one, we would really be able to support use cases across all those 6 usage scenarios? So I would appreciate your thoughts on that. Thank you.
So I guess the question is almost the same as in the previous slide, presentation from Japan. I guess we cannot we have to prioritize some of the use cases here. I don't think we cannot be satisfied all the use cases at the same time in the beginning. So we need to think about that, which one is more important in the first.
So basically, what the question, if I extend on that one, is this 6G forum is going to go through some prioritization because the work is going to start in SA1, right? That's so what can we expect that 6G forum through their members will bring some contributions to 3GPP, highlighting what are the day one or like a high priority use cases they would like to be enabled from 6G?
Yeah, getting back to Korea, then I think I'll need to discuss this issue with chair of the executive committee. Maybe I'll talk about that with Kyung-hee Chang, Professor Kyung-hee Chang. Okay.
Thank you. Other questions? So yes, ma'am, please. You know your name.
Thank you for the presentation. This is Xiaonan Shi from China Mobile. I noticed you also mentioned the integration of communication and computing in your slides about the R&D tendency. So if you have any specific idea, like what scenarios or use case you're considering to do this such coordination, and what kind of enhancement do you think is needed for the 3GPP system? Thank you.
You mean thank you for asking. You mean the communication integration with communication, right? Computing, yes. Computing integration. Yes. So I guess when you mention computing integration, computing with communication, that is also related to AI or any other services that can utilize computing in the network. So the scenarios will be related to AI or maybe later, LLM as well for the services.
Yes, and after that, do you think there's like some enhancement on the functionality levels of like core network or like RAN level, or do you think it's just like upper level information exchange or such kind of thing?
There will be also my personal opinion on this one as well. I think we also need to think about some changes in the core network to support this computing integration into communication, but also some kind of API level or application level orchestration issues will be also involved.
Thank you.
Okay, thank you.
Thank you. I think we still have time for maybe 1 or 2 more questions. Yes, please.
I'm from SoftBank, Daisuke from SoftBank. Thank you very much for your presentation. I think you mentioned that the coordination of 3 drivers are done in 6G forum, and it is quite important to have an alignment between market needs and the technical push. These two blocks on the bottom, and I'm just wondering how it is being done in 6G forum, because yeah, in my experience, this kind of discussion tends to run into chicken and egg situation, that what can be done from technical side, or what do you want to achieve from a customer side. So I'm just wondering how this coordination is being done in 6G forum.
Because thank you for asking. Because we have member companies from various industries. So some are related to customer side and some are related to industry side. So we are gathering the opinions from different areas that can I guess as you said, it is not an easy job to harmonize all those issues together, but we are trying our best to harmonize the societal requirements and also technological advancement.
Thank you. Maybe last question, Nicholas.
Thank you. What do you mean by 6G assisted navigation?
6G, thank you for asking. 6G assisted navigation is 6G connected navigation. So there can be remote controlled navigation as well, or maybe sensing is also related to that. Yeah. I guess, yeah, 6G assisted means like from radio technologies, and also the application connected through the 6G radio.
Okay, I think that's all the time we had. So once again, thank you very much. Let's give a round of applause to Dr. Nimsak. Okay, so we're gonna have a coffee break now. So what we have after coffee break, we have to swap the presentation. So we're gonna go with the Bharat 6G Alliance presentation first because it's been delivered remotely, and we will try to do the technical things sorted out during the coffee break. So that's the reason we swapped the presentation to be able to work on that one. So let's come back at 11. Thank you.
Good morning. Hello. Am I audible? Hello. 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 हेलो अरे लेकिन आवाज तो मेरी टेस्टिंग तो कर दें सब तब ठीक है तब नहीं करेंगे नहीं नहीं उसको पहले टेस्टिंग करेंगे हेलो हेलो या आई थिंक आई एम ऑडिबल Hello. Good morning. Am I audible? Hello. Hello. You just want that show my screen. Is it visible? Sorry. Sorry, actually my what is here. Seal we just go, no issue. Yeah, screen is visible. So let me open my presentation. This is the presentation, and now I'm making it in this mode. So it's okay. Hello. Am I audible now? And in fact, let me check. I think I am moving my cursor also. Perhaps it's working.
So, but we need to see his voice goes on to those speakers.
Yeah, I think it's going
that's
to
okay.
someone.
You will test. Okay, so speak something.
Good morning. I am Rajesh Pathak from Bharat 6G Alliance. So perhaps I think I am controlling even audio also.
Okay, so why don't you?
Rajesh?
Yeah.
Camille, I'm speaking with the microphone now.
Yes, I think it's clear, very clear.
Okay, very good. Thank you.
So we'll start at what time? After 15 minutes? Okay, thank you. I am bringing that, yeah. Thank you for the testing. No, I won't exceed the time. Yeah. Yeah, I think it's same. Sure. Yes, I will make it. Yeah. बाद में इसी बंद कर दूंगा। बस 2 मिनट में वाले लोग 2 मिनट में 30 मिनट प्रेजेंटेशन 15 मिनट क्वेश्चन। ज्यादा ज्यादा ठंडा कर दिया हूँ जिससे कि
Hello. All right. Can we please close the door and get the people inside? All right, let's come back. Gonna start closing the doors. Okay, so welcome back. So our next speaker is Mr. Rajesh Kumar Pathak. He's a Director General of Bharat 6G Alliance. And prior to joining the Director General position in Bharat 6G Alliance, Mr. Pathak was a member secretary in the high-level forum for 5G India 2020 and implemented Make India 5G Ready. He was also member secretary of Technology Innovation Group in 6G and played a strategic role in Bharat 6G vision document and setting up Bharat 6G mission as its head. And I mentioned earlier, since he could not be here due to the visa issue in the last minute, so we try to have his presentation done remotely. Over to you, Mr. Pathak. Please proceed. Mr. Pathak, can you hear us? We cannot hear you.
Hello.
Yes, please go ahead.
Yeah. Thank you, Dr. Puneet. Very good morning, good afternoon, and good evening, and namaste from India on behalf of Bharat 6G Alliance and people of India. So I'm sorry that in spite of my best efforts, I could not join you in the physical mode. And I feel humble and honored to be one of the presenter. I have been a policy person, and from policy to technology, it's more exciting, challenging. And thank you, 3GPP. So let me start with the Bharat 6G vision. Bharat 6G vision have been launched by Honorable Prime Minister on 22nd March 2023, about 1 year ago. And its vision is that design, develop, and deploy 6G network technologies that provide ubiquitous, intelligent, and secure connectivity. So whatever we are doing in our this alliance, that is to achieve these objectives. So I think vision objectives. So I have made my presentation outlined that what is the 6G vision, introduction to Bharat 6G Alliance, from where I came, and more important, our Bharat India's 5G experience, because I think that will give the guiding, that will be a guiding factor for 6G. And then comes the six key 6G use cases, drivers of the 6G use cases for 6G and beyond, societal needs, sustainability, which is one of the goals of vision statement, ubiquitous, reliable, and secure connectivity, how can we achieve it? And then what are the various Bharat India's initiatives? So I think I will be giving you this in details in my subsequent slides. So this Bharat 6G vision, it has 3 pillars, and it's affordable, sustainable, and ubiquitous. So we have to meet that 6G meets requirement of all the 3 together. Perhaps it will be the case for other similar economies where we have the rural areas sparsely located. There are difficult terrain and at the same time dense population like in cities. Thus, along with connectivity, coverage is also important. For India, affordability means the ARPU in the range of $3 to $4. So thus, while it has to be sustainable, ubiquitous, and at the same time affordable. So this mantras we have to keep while designing the system. Next comes the, I think we are committed for the innovations for the world. It's not just will be, I think, working in isolation, but we are open for collaborations with others. We have presently 1.2 billion connections, and about 900 will be the broadband. It's here, and we see technology, especially this telecom, as a digital transformation vehicle. It will be for digital inclusion for the people of India. This Bharat 6G Alliance is an alliance of industry consisting of public, private companies, academia, research institutions, and it's supported by the government. It is the new alliance for innovations and development of 6G and allied technologies. It has more than 40 members and it's growing. It's not for profit society for facilitating realization of Bharat 6G vision statement of India and closely working with the different wings of the government department. We realize that startups have the greater role in innovations and development of frugal use cases. You will all agree that one of the pain points of 5G and even linked with the revenue generation for the service providers have been the use cases. So we will be working on all those aspects, including coalition with the like-minded global partners on 6G and associations. We facilitate the availability of 6G test beds in private, government, and other academic institutions, and even access to 6G chipset in technology. Let me briefly discuss this Bharat 6G alliance structure. In Department of Telecommunication, we have government's 6G Apex Council headed by Honorable Minister, and it's continuously interacting with Bharat 6G Alliance, which I just shared. It has a governing council. It may have expert committees. Presently, we don't have, and then working groups are below the expert committees. So, and then depending, we have the coalition partners also. We'll be working on various items shown here. They are just indicative that 6G research for business societal needs, design and build AI/ML led 6G products, startup manufacturing ecosystem, patent and contribution to standards, and market access. As regards the working groups, so I think we have seen that most of the cases, all similar research associations have a spectrum. Device technology sensor manufacturing. So here I would like to just say that we are saying that it has to be affordable. So for getting affordability, we have to work on all aspects of technology, not only the access part, but device part, UAE part, mobile, and sensors, because I think it will be more important that whatever are the IoT devices and how they can be manufactured within the country. So this is also thought process, and they are working on that. Technology, as we know that that's the access and others technology, maybe the new technology as well. We have applications, green and sustainability. These are some, I think, like others also. But this last use case, 6G use case and revenue stream. So this is very much important, perhaps we feel, because we have seen that in 5G also, it's the revenue stream which is important for a TSPs. If they don't get revenue, then I think they won't take their buying decisions, whether it's spectrum or it may be investment decisions. So I think we have to make 6G in such a way that from day one itself, they get revenue such that they participate in technology. In fact, that is also one thought process, that operators should be integral from the very beginning itself in the development of technology. So these are the various, it's I think technology stream, MIMO, user defined virtual air interface, HAPS, LEO. So we will be working on all these technologies. Let me share the Bharat 5G experience. And in this experience that we rolled out our 5G on 1st October 2022. So it's, I think, yeah, more than 18 months. And in 18 months, there are more than 435 5G cell sites deployed. 5G services available in every state and union territory. 135 million active 5G users. In fact, this growing. And more affordable cellular services globally. It may be one of the pain points for the operators also. And we have deployed both SA and NSA in FR1 as well as 700 megahertz. Main business case has been the mobile, and I think it's not that we are not working on others. That will be seen subsequently. 5G adoption investment will continue to grow in India over this decade. So I think we have to keep this in mind that once operator is investing, then I think he would like to have the revenue stream. This is the global index ranking among selected countries by Ookla. So that is of October 23, in which India improves its ranking from 72, 47 places, 119 to 7. Yeah, 119 to 47, 72 places. However, the latest report of March, it's indicating 16th place. So I think this is, I think, very excellent development that India and its operators, its other ecosystem partners, they are working in this. Let me just say that I think we are the one of the mobile first market with highest data consumptions per smartphone globally as well. For those India's 5G journey, it's important that we share that what all we are doing in case of use case development, and these are some of the, one can say, print media that Airtel successfully reached first 5G private networks at Bosch Automotive. So this is just, I am indicating that we are working, TSPs are working, and independent, in fact, government and others industry with the market participants for development of use cases and how to make revenue and viable TSPs. So many trials are going on this. Okay. This market evolution in this decade. So once I am showing this slides, so I think I have started now. I mean, what is the topic that use cases? So I think it will come from this evolution part itself. So like current scenario, it says that 5G market potential yet to mature. We are doing broadband. Commercialization of URLC and MTC yet to fructify at scale. Why I'm saying so, that EMBB was, I think, evolution part, whereas once we go for these two below that those were part of the triangle, URLC and MMTC, they were really real revolution parts. So I think we have not utilized the revolution, but merely evolution that is from 4G to 5G, and that was never intended to. Business opportunities and regulatory steps will continue to evolve. Now let me say expected scenario around 2030. SA along with 5G will be mature, and I think that will be the dominant deployed all over the country. This deployment will be in the low band, mid band, and possibly wave at also, because it's possible that there will be so many FWA devices developed by that time. 5G would have just overtaken 4G in terms of global subscription, and there will be large scale deployment of 5G and LTE based IoT devices like RedCap, NB-IoT, and CATEX in industrial and B2B to C development. And further, there will be some monetization of network APIs as well. So we have to keep in mind that we are going to stay in the network, and we have to make sufficient provisions for the backward compatibility as well. And further, I think other speakers also touched this point, that we have to work in such a way that there has to be growth and penetration of non-3GPP and other technologies. So I think we have to keep, while designing our system, this also. So what are the various 5G learnings and 6G expectation? So huge gap between 5G promises and unfilled deployment. I think this was stated by others as well. Vertical industry is still in very early phase. It's the use case. Enabling MBB and FR2 remains a challenge in 5G. I'm sure that we will work together in doing this. Sustainability measures in 5G were an afterthought. So I think this is very much important, that from the very beginning in 6G we are saying sustainable, ubiquitous. So all those things are very important, that while design we think through on those. And too many architecture options for migration from 4G. So we have to keep this in mind, that how to take care of in case of 6G. These all the learnings we have in the 5G. So realistic assessment of new use cases in verticals is crucial. Spectrum choice shall be aligned to usage scenario. Profiling 6G technology. So here I just want to say that under profiling, we would like to propose that use case is specific as is identified in M2160, because they have given certain things. So if we do the profiling as per use cases there, perhaps that will be a good business case for our operators. So this is my thought. I mean our association's other thought. Sustainability should be foundational basis of 6G definition and smoother migrations from 5G to 6G and 3GPP to enable open interface in 6G RAN, ensuring no vendor locking. So 6G use cases have to be practicable and monetizable. So this should be the thought process. Let us just discuss that what are the 6G drivers we feel that we have. And the more important is growing capacity and reducing TCO. So on that, energy efficiency consumption, sustainable and expansion of infrastructure is important. Capacity expansion with cost-effective network upgradation, improved coverage, efficient spectrum sharing. So I think there, how can we utilize even AI and others also for improving sustainability and in spectrum domain as well. When it comes to new revenue streams by new use cases in 6G, affordability to offer new services from investment, that because any new investment should be in a way that it generates the revenue for the operators, even for the others equipment vendors as well. And 6G use cases for agriculture. Why I am referring to agriculture, immersive education and healthcare, that we have a thought process that perhaps for India, a country like India, its education and healthcare is very much important. So how can this technology help our educational institutions starting from the school level to the professional level and healthcare system, healthcare, so many devices. Otherwise, I think it's being just developed by a couple of some individuals and it's not being taken care of. Including scaling 5G applications like cloud gaming, I think that can be the one of the revenue stream for the operators. Connect automotives, collaborative industrial applications. So once we say in industrial applications, so I think there will be so many ingredients at that time, and logistic can be one of them, airports can be one of them, railway can be others. So there are so many, and in this case, drivers, we have a thought process that government has important role to play. Government means different wings of the government, because I think they feel that it has been the subject of individual departments, but I think entire government and industry has to come together for making use of this technology. Expectation from 6G. Under expectation from 6G, we feel that architecture and design principle, that design key new use cases based on the thorough due diligence and not just speaking on peak capabilities, enable localized use cases, specific deployment for offering 6G services, 3GPP to open interface for 6G RAN, I think I have told, for interoperability, support native applications to meet regulatory obligations like voice or legal interceptions, positioning, etc. It may be required. Be business driven to coexist with 5G and 4G networks. So this is also, I will place here more emphasis on this, that since 4G as well as 5G both will be there, so how can we design in such a way that operators find it, one can say, even revenue neutral. Ability to do 6G in existing bands coexist with 5G. And in case of course, software upgradation of 5G to support 6G RAT along with 5G. Simplified network deployment option. AI native and programmability. Under this, we feel that support for interoperable AI framework for network and device performance improvement. AI management, control, user plane, security monetization. 6G system as a platform enable right APIs in the multi-systems. Holistic automation of networks and services. Sustainability as a design aspect. Sustainability should be part of 6G design, energy efficiency, radio interfaces, network load balancing, etc. And security is more important. Here, I think it comes the quantum. So we are working and we have set up quantum mission as well. So we feel that we have to work on that. A provision to reduce national level security requirements as if required. So next comes the driver for the 6G. So under these drivers, it will be new communication services, enhanced voice, immersive communication, 6G based low power wide area networks, including continued support for 4G, 5G IoT services. Beyond communication services, we feel that integrated network based sensing and service exposure is important. Network ability to offer AI and compute as a service. Trustworthiness in network for service exposure to various industries along with government agencies and sector. Traffic, public safety, security, surveillance, health, agri and education. Why I'm saying so, that maybe so many cameras are there, but I think perhaps they are not intelligent enough to predict any thing happens at a street or at any place. So they are subsequently analyzed. So I think we have to make in such a way that we utilize this technology, even existing technology, for better traffic, public safety, security, surveillance, and naturally health, agri and education, as I told earlier. So reliable 6G, voice over 6G, I think that also we have to think that how we say, and GC with built-in AI, 6G node B, we are referring to here TN as well as NTN. 50 GPON based XHAUls, self-healing management planes, self-organized networks, integrated access and backhaul, RIS, and coexistence with 4G and 5G. So this is the thought process we have. Perhaps I will say that it has to be based on the 5G success and do more in efficient, economical, scalable, sustainable way. These are the certain use case family we have shown on the latency and data rates. So one can see on the lower side proximity connectivity, so network sensing. Then if go to latency in higher, then global connectivity, next G, EMFB, and dependable real-time communications and short-range UR. So these are the various things we have plotted here. Now it's come the current research focus. Under the ubiquitous connectivity, we are working on improving connectivity through TN as well as NTN, and targeting coverage distance of, it should be TN more than 8 kilometers and coverage area for NTN, actually that have been decided. Targeting more than 1 GPS user throughput and peak throughput more than 25 Gbps using TN. Targeting a few Mbps under the throughput under the NTN. TN extension enhancement through relays, IAB, RIS, and extreme MIMO. Support of mix of 4G TN, 5G TN NTN, and 6G TN NTN network from 6G. In fact, the mobile handset should also support, such that I think as a user I should not know whether I am moving in TN or NTN, and it should be, I think, seamless. Core evolved from 5G to support 4G TN, 5G TN NTN, and 6G TN NTN. Energy efficiency and coverage expansion through new waveforms if required, and I think we have to go for that as well. Support for voice over 6G with high reliability. So it's emphasis here I will be giving on high reliability part. Integrated sensing and communications, I'm sure that all are aware of, and we are thinking a lot of applications in transportation system. Use of multiple FR2, FR3 bands to improve sensing capabilities. And able to support sensing in a standalone mode as well, maybe for a specific service scenario, use case scenario. In case of immersive communications, we feel that holographic communications, telepresence, robotic surgery, digital twin for smart cities, factories, healthcare infra. In fact, we are right now doing, we have taken this project digital twin for smart cities from the government initiatives. And I think that will give us a lot of insights for that, how can it can be utilized for taking the decisions at the very early stage, during even once its project is going on, and how can we utilize it for safety, security, others thing. So in case of smart cities, but for others also, I think there are so many use cases. AI and communications, AI for improving radio network performance, improving positioning, sustainability. Asset tracking, we feel that batteryless asset tracking important, and IoT NTN for asset tracking. Convergence of broadcast with fixed and mobile broadband. We feel that I think that should be also enabled in 6G. Briefly, I will just cover this sustainability societal needs. I am sure that this is covered by others also, so I won't give much time here, but I'm just showcasing here that we have a 6G working groups on green and sustainability, and they are working on network energy efficiency through network planning, automations, implementation. And I think based on our realities, what can we do to reduce this sustainability part? Sustainability very important, that we have to design, develop 6G, keeping a sustainable telecom infrastructure key, and same time work on e-waste recycling models, carbon footprint reduction, improving network efficiency, and how can we make our cities sustainable for the others generations when they will come. So let me just go for the Bharat 6G initiative. So this is a slide indicating that we have certain, one can say, success in case of 4G and 5G. We have one of the scheme called Jan Dhan accounts, financial inclusion program, and Aadhaar is a digital identity and mobile. So once you combine this, then we come to JAM. So it's called JAM Trinity. So basically in India, even a person having mobile can do the banking transactions with the help of this, and how digital services can improve the life of the persons, ubiquitous, secure, trustworthy across the communication network. So this, I think we are already doing. Lot of things are working on the know your customers, OTP, and mobile banking. So we are sure that 6G networks to be trustworthy, reliable for advanced service delivery with chain of trust and increasingly vulnerable cyber world. Once it's come the societal goals and initiatives, so I will just place on records that we say that a stepwise plan for greener India includes achieving net zero by 2070, reducing total project carbon by 1 billion tons till 2030, increasing renewable energy components 50% of total energy requirements, reducing carbon intensity by 45. And I think it's not telecommunications, but all other government departments, institutions are working together, and we feel that ICT can be key enabler for the same, in addition to reduce its own energy consumption. Let me share certain national R&D initiatives. So we have invited this call for proposals on accelerated research on 6G ecosystem. We have received more than 450 applications. We have already 6G end-to-end communication system supported by the government in academic institutions. Extreme MIMO testbed is present here. Advanced optical testbed also supported by the government. Terahertz testbed with orbital angular momentum multiplexing. So these are all the projects which have been supported by the government. But in addition, there are so many 6G testbeds in the private sector. And they are all working with the startup MSMEs here. Digital twin, as I shared, that for we are doing right now for one smart cities, and that will be, I think, replicated in others. We have one AI for India, Bharat we say. So to position India as a global leader in AI, and we have national mission interdisciplinary cyber physical system. So basically there are 25 hubs, and they are working on the different discipline of technology. So we are sure that this will be a true example. Those all the 25 centers for development of 6G. We have about $1 billion in case of quantum mission. Same is the case of AI mission, and even Department of Telecommunications over in 5 years. I think we will be having. We call it about 100, more than 1 or 2 billion R&D. And we are leveraging this with academia, startups, R&D labs, with support from industry, telecom service providers in 6G, use case development. We feel that I think telecom service providers from India have a greater role to play in technology development from the very beginning, because I think trials we started doing once I think this technology, I mean standards were closed. I think we have to do from the very beginning. I am sure that we will work together. In summary, this is perhaps I think I'm in time. So in case of general considerations, so let me say that monetization should be central to evolution. So we have to keep in mind that when 6G comes, then I think and that should be monetization should central. Leverage 5G investment and enable smooth evolution in meeting future requirements. In fact, industries using 5G and 4G with long life cycle should continue leveraging technology. 3GPP need to consider evolution and relative strength of other non-3GPP technologies in the next decade, because I think that's I even shared during one of my earlier slides as well. So we have to keep that in mind. Once it comes that what are the various considerations on 6G, so network need to be G agnostic in future. Perhaps I think that's more important, because if TSP has invested today or maybe after 4 or 5 years, he is not going to change certain elements. So how can we make it that with the help of mere software upgradation, he can achieve this? And the core to handle 6G and 5G RADs, simplified network deployment path, 3GPP to enable open interfaces in 6G RAN for improved interoperability across building blocks. Expectation and field performance should be aligned. It should not happen like in case of 5G, there was certain, I think we could not achieve. So this is the, I think inputs I have from my members. And ubiquitous connectivity ensured through multiple spectrum bands across terrestrial, non-terrestrial network technologies, voice over 6G, energy efficiency, coverage, sustainability, native intelligence need to be part of design and not an afterthought. So with this, I think I have shared and the 6G, this RAD should be backward compatible in existing bands, able to coexist 5G and smoothly migrable. In addition, I think I have that from India, I would like to invite you all to WTSA 2024, that is from 24 to 25 October in New Delhi. So this is from Bharat 6G Alliance as well as from the Government of India. And we have proposed one session on 16th October on 6G Global Vision. It can be renamed something else, and it will hold the event. So you all are invited to be part of this WTSA as well as this 6G Global Innovation. So I think let me come back again on this part, and now I'm open for question and answer. And thank you 3GPP and even other presenters to whom I could not meet in person, because I think I realized that even all the presentations, even yesterday, were very informative for me, because they were from other institutions like some automotive, some satellite, and even MAG, etc. So thank you all. I could not meet you, so that I'm just missing. With this, I'm open for the question and answer.
Thank you very much. Let's give a round of applause.
Thank you, sir.
Thank you, Mr. Pathak. So I think we have time of a few questions. So from the room, let's see from the front, Eric, please. If you may say your name and company.
Hello, my name's Eric Upman. I work for Samsung. So I used to be a software engineer, and we used to say that there was a triangle. It could be good, fast, or cheap. Choose two. So now I'm a standards engineer, and we have 6 things we're trying to do. Affordability, ubiquitousness, sustainability, coexistence, performance, new features. So which 2 do we choose? That's a facetious comment. So, but in reality, if I look at this with all respect, I see that there's a clear vision for basically extending mobile access in an extreme way to all people. So to me, and I'm going to daringly suggest something, and I'd love to hear your response, that affordability, ubiquity, and sustainability are the key features, and that we will sacrifice, right, because we have to sacrifice something, coexistence and performance. Otherwise, we cannot reduce complexity. If we don't reduce complexity, then we will not improve sustainability, we will not have ubiquity of access, and it will not be affordable. So I'm asking, is actually extending the service in the way that you suggest in a sustainable manner actually going to require us to reconsider coexistence and our performance requirements? Thank you.
So Mr. Pilot,
Yeah.
do you want to?
Yeah, actually, I am not the person of standards, but though I think I have the feeling that we have to work on all the ecosystems, like even I told device along with the equipment, etc., and keep in mind that how can we achieve this coverage. One can say universal coverage, or so many words are there, but it's the challenge for the standard community. Though I think whatever you told, I fully agree, but it's for open for the 3GPP and other technical persons to, I think, discuss it and then decide. This is from my side.
Thank you. Yeah, I mean, what we have heard from the panels yesterday, also a question I think from the audience was about AI and its sustainability. When we say about the AI is gonna be one of the big driver for 6G network, but we also know that basically AI brings a lot of energy and computation usage, so which is going against the principle of sustainability. I mean, obviously this is a good challenge to have, and that's where we do well in 3GPP. We'll look at all these requirements, even from the verticals. What we have seen sometimes is, there are conflicting requirements. Not everything can be done in one release, or maybe we take a a phased approach. So, but this is a good problem to have, I think. Okay, next question. You go from the back, please.
Thank you. I'm Cristina Romavera from Vodafone. This is a great presentation, and I have a question about one of your points. When you mentioned low power wide area, you said that we have to support 6G, so on, but with the continued support of 4G, 5G, of IoT devices. So do you have any plans, or do you have an idea how are you going to achieve that? Thank you.
No, in fact, I don't have any plan. So these are the requirements, and actually we're working on those. So that's why there are the working groups. I'm sure that they will keep these suggestions in mind in Bharat 6G Alliance, as well as I think that will be open for the 3GPP, that how to make it that I think all work together.
Okay, other questions? Ian in the back.
Yes, thank you. Ian Sharp from Attis. In a couple of places in the presentation, you mentioned 3GPP supporting open interfaces in the RAN. Is that basically suggesting that 3GPP takes over some of the work of the O-RAN Alliance? Thank you.
No, I think it's never intended, but I think vendor locking, definitely that's a thought process, that it has to be open interface. It should not be that it's a proprietary. So how to achieve it? How can 3GPP and O-RAN? I think O-RAN will come here, perhaps. That is my thought process. Okay, I think both have to coexistence, and they have to come here and work together. That whatever they are discussing, how can that be included in case of 3GPP? That's my thought process. Perhaps I think others can also think through, but that is important, that there should not be any vendor locking or maybe some proprietary deployment which creates the future. Because I think people say that this should be the G agnostic. It means we have to keep all our pain points, whatever we have in 4G and 5G. So that should not happen again in this, and it's software upgradable. So perhaps this is the thought process, and I'm sure that should be looked into.
Okay, Amitava, please.
Thank you, Rajesh. This is Amitava from Nokia. So I have a practical question. You have talked about Jam Trinity, which improves the life of paper. My question is directed towards people like senior citizens and people who are not technologically savvy in India. How are you addressing digitization with this group of people? Thank you.
So those who are not technological savvy also, they are covered under the JAM committee. So because if simply I have seen that a vegetable vendor on the street, he has just displayed a QR code, and whatever amount you just scan it and you pay him. So that will go to his account, okay? And sometimes they don't have the account as well. So that's the case of digital inclusion part. We have Aadhaar identity, so that's being linked at all the places, and you'll realize that even in case of airport, etc., with the help of this face detection, etc., lot of things are being simplified in India. We call it Digi Yatra. As far as elderly people are concerned, right now we are working in a scenario that even if I speak in local language, I go to ATM, that is a typical use case, maybe somewhere are operational as well. If I go to an ATM machine in a village and there I speak in my local language with the help of my voice authentication, with the help of my iris, etc., technology should enable, maybe I think when 5G itself, that it will be feel like I am in the bank itself, and all my work, which otherwise I have to travel to a bank branch, can be done by illiterate person I am referring to, and with the help of technology. So that can be possible even in 5G, and even in 6G we are expecting more, because I think a lot of sensing and other components will be added in the years to come. So we are working on that also. But I think if you are directing towards something like Japan told that for elderly people, so I think that will be a reality for anyone in the world, and we have seen that that is required, that we have to use technology for elderly people. And how can we work so many use cases, though they may not be revenue generation, but I think we have to work on that.
Okay, I think we are out of time. So thank you very much again. Let's give a round of applause to Mr. Pathak.
Thank you, sir. Thank you.
Thank you very much. Okay, so we're gonna switch, Ellen, right? Okay, good. All right, so let's welcome our next speaker. Our next speaker is Ms. Yang Du. She's a senior engineer of China Academy of Information and Communication Technology, which is CICT. She is vice chair of standards and international cooperation working group of IMT2030 6G promotion group. And she has contributed to a research, evaluation, and standardization. Now she focuses on 6G technology research and verifications. So welcome, Ms. Yang.
Oh, it's okay? Okay. Thanks, Chair, for your introduction. I'm doing from CST and also work for the IMT2030 6G promotion group in China. And it's my pleasure to attend this workshop to share our view on use cases toward 2030 and beyond. So in the first slide, I will give a very brief introduction on our promotion group. Our promotion group represents the frontier progress of 6G technology and the industrial development in China. And also, I just give the group structure in this figure. And now we have 6 working groups focused on requirement, spectrum, wireless and network technology, standardization, and some study on social and economic impact. And also we have another task group. It focuses on the 6G trial to verify the technology, to solve the ability to support some use cases. And I only have included one slide for our introduction of our promotion group. Maybe I can give some more details orally. And now for this workshop, we prepare these slides from the with the supporting from the requirement working group, the technology working group, and from the standardization working group. And also the for the requirement working group, it focuses, it just follow the ITU, and later we follow the 3PP timeline to do some research on the vision requirement. And now we focus on the TPI for ITU following working. And also we have published 6G vision, 6G requirement, key technology trend, and the key scenarios and something like that in this working group. And also from the wireless and the network technology working group, we have published about 40 white paper or technical report, including, for example, for the AI, for ISAC, RIS, terahertz, and also some important element of the new network capability, for example, computing and data service and something like that. And also in our promotion group, we have more than 100 members from industry, university, and research institute. And also our working group is open to the world. And we just give some company or university or research institute logo in this slides. And in this page, we just give very high level driving forces from outside for 6G. For example, for the economy sustainability, we think maybe how to satisfy the industrial digitization is very important from this point. And also we have the jobs from social sustainability and environment sustainability. For example, green development and many energy efficiency and something like that. And also, we think also the technology innovation is very important for driving forces. For now, for example, for some emerging technologies, integrated technologies, and the new materials development in the window of 6G. So for the main goals, we think 6G will achieve intelligent connection of everything, deep integration of virtual and reality, and digital twin. And in following slides, I focus on two parts. First is key 6G cases, and the second one is a roadmap for 6G. Oh, we also gave this picture in the previous slides. So I think the ITU have given the typical 6 usage scenario. The first 3 scenario is just extensive scenario from 5G and 5G advanced, and the other 3 scenario is just the new scenario for 6G. So we think beside the usage cases or scenarios, we should sort how our 6G network to support these services. And so we think we need the new network capability from the system level. So in our slides, we will show our beginning view on the network new capability to support the diverse usage scenario in the 6G time windows. For example, for the new capability, I focus on the three new elements, including distributed network, user-centric network, and mobile commuting network. And also, we always need the efficient network operations. And also, we should consider sustainability, security in our 6G system. And from our point of view, we think we just give some highlights of the usage scenario. We think AI and communication, integrated sensing and communication, and the industrial IoT are prioritized in addition to immersive communication. In following several slides, I will give the introduction on the use cases one by one, and just began with the high priority use cases. This slide just gives our some opinion on AI and communication. We think in 6G native AI design will provide AI as a service. And we think it includes two parts. And the first three elements is focused on network for AI service. And the final one is focused on the AI for network. We can begin with the network for AI. First of all, we need the collaborative and distributed interference to support the cases among robot swarm, to support cases, for example, global multi-metadata fusion, and also to support the multi-agent communication and interference. And for the second one, it is multi-node distributed learning. And we think we should support some function to satisfy some cases. For example, site-specific model for smart city, factories, and homes. And also support the personalized model fine tuning with privacy protection, and also to support the hot LLM training in our 6G network. And also data model management is very important in our following 6G network. For example, we need to support the on-pass data processing function on how to utilize or manage data and model. And for the AI for network part, we think we should support AI for network enhancement, intelligent network management, use the AI method to get more efficient energy utilization. And also we need to support the AI assisted air interface. So from the 6G system level, we think 6G should support the comprehensive AI service design, and to meet AI service with diverse requirements. For example, for various accuracy, latency, and diversity. And also support AI for 6G network architecture and air interface. The second use case is integrated sensing and communication. I think we think this scenario will provide multi-service, including sensing, positioning, and communication for 2C and 2B. And we just give some typical for sensing mode here. First is a localization, tracking, human activity, recognition, and environment object reconstruction and monitoring task. And also we think now in 6G advanced, we just have some work on this topic. But I think in the 6G we have more space to design or to realize more diverse cases. So from the system level, we need the high ISAC performance to enable low altitude economic growth and form a truly scale market. Maybe I will use 1 minute to give some more detail on the low altitude in economy in China. And now in some city, including Shenzhen, Chengdu, and Guangzhou city, we have some network trial to support the UAV tracking. So and now in China, the low altitude economy catch very high attention. So we think in 6G system, we think we should consider this point. And also we need the high accuracy sensing and positioning in wide area coverage. We think it will use our benefit of the cellular system. And also we should consider how to get efficient sensing data utilization. For example, the multimodal sensing integration and the management, integrated AI and sensing to assist the communication or positioning. This slide gives our view on the industrial IoT. We think we have long discussion on the vertical application, and we think the industrial IoT is high related to HRLC scenario, but also it related to the low latency broadband or something like that, even related to the massive IoT. It's not only the high reliability and the low latency, it covers a very big area. So we think in 6G we should further improve the productivity and operation efficiency in industrial manufacturing. And in 5G we have we have used the 5G technology in many industry. For example, in the mining, in the steaming factory, in the automation factories, we have get some nice feedback from the industry. But also we realize some gap from the 5G capability and the real requirements from the industry. But we think the issue is very complicated. It is not only about the performance. We should think it from the system or from the service level to consider the issues. And also in 5G, industrial IoT was not natively supported in day one. Maybe in day one we support all the ITO requirements, but it focuses on the link level. And also in the following release, for example, for the release 16, we have the we have to optimize our system for URLC, and in release 17 we have some solution red cap for some massive IoT. But all the feature is introduced in later release in feature by feature way. Each delayed the deployment of IoT in the market. I think in China, our 5G network is following mainly following the release 15, and we just wanted to introduce some URLC feature of release 16, and now we will deploy the red cap network in this year. So, and the clear requirement at the gap can be identified in the market. It's just related to performance, efficiency, and cost. And in the middle, we give 4 typical uses cases. I think in this industry, it is we have deployed our applied 5G technology in this 4 industry. It's the best applied in this industry. But also in our experience during 5G, we realized more gap or some problem to be enhanced in the following period. First is collaborative robots and machine vision and AI or ML for the defect detection, and also the industrial sensors and smart grid. So for the system requirement, we just give 2 parts the information from outside. Also, we need a high performance, including latency, jitter, reliability, robust synchronization, or data administration, capability in the following system. Also, we have the uplink capability in improvement to facilitate some broadband requirement in the factories. And also, we think we need some enhancement on the service capability, and also it including the ability to deploy the values more easily or more and with high sustainability. And so also the industry is very sensitive to the complexity and the cost. So we think the cost is a big issue for the deployed in the vertical industries. And also we think we should consider the implicit framework for edge for the edge computing and network capability in browser. We think it will be benefited the service capability. For the immersive communication, we think it is the base of the 6G system. It will create an immersive experience, achieve high fidelity experience, and something like that. And also, we think in the immersive communication, it will cover cases about the interaction between human things and the environment, and also the human to access, for example, to the person AI agent, robot, something like that. And also, we need a large computing demand besides the high performance of communication. And also, we support the multimodal interconnection to get the better experience through our 6G system. And also for the ubiquitous connectivity, we think we have a good start in the 5G. And also we think maybe 5G can be the start point for 6G design. And also we have the big space for the design for 6G. For example, we have the new requirement on elastic and scalable network architecture with adaptive network node expansion and coverage adjustment. And also have the efficient interworking between ATN and TN and the high service availability in limited coverage. And also we can support network sharing or satellite sharing in our following 6G system. And the following three slides, I will introduce some new capability from the network point of view. First of all is the distributed network. We think the distributed network can meet the diverse dynamic and localized business requirements of 6G. It presented a trend of distributed and also the autonomous development of our network. We just give three typical cases interworking between 2B and 2C network. And also we think the 2B network it is close to the user. And for the second one is the autonomous campus network and also the inter-network disaster recovery coordination. So in this point of view, we think the 6G can support more flexible and dynamic and agile network deployment mode. And also we can support interworking between isolated 2B network with 2C network. And also the 2B network in edge, maybe from some industry, they require for local control, including access, sensing management, and subscriber management. So some core network function will be pulled into the edge side. And also we can support the quick response and solve time for network service by distributed network. This for the user-centric network, and also we think our generation system is supported for user. but maybe we can in 6G we can get somehow a high efficient user-centric network. I think the user-centric work can support the NGO network deployment, customization, and coordination for users. And for 2C user, we can provide the user a configurable heterogeneous network following them. And to B business and the tenants achieve a dedicated customization system configuration. And we think maybe in 6G system, the network service can be deployed and customized by user dynamic in real time. So with the user-centric network, we can got user-friendly customization and configuration of network capability, and we encourage multi-mode participation in capability collaboration, coordination, and invocation. And for the mobile computing network, it is highly related to the AI. And we can control and scaling the ubiquitous distributed communicating resource and provide cloud edge use of end-to-end collaborative computing services. And we just give 2 examples. First is UE computing offload. We sort of support through the system capability. We can provide the computing node with the shortest transmission path and lowest latency. And we sort of support the computing node selection, resource allocation, and task management, something like that. And also we should control the distributed computing resources. For the sustainability, and we have many discussions yesterday, and also we think we should support the energy saving technology from the beginning of 6G system, and provide the end-to-end energy saving solution. And also we can efficient use of the renewable energies, and support the self optimization and self-organization with green advanced technologies. For the security and the trustworthiness, we think 6G will build an active, intelligent, resilient, and efficient trustworthy security system. Maybe we can support 3 parts of security and trustworthiness. First is the intensive security capability. For example, to support the ultra high data rate communication, and to support the lightweight mode authentication for IoT or NTN, something like that. And also we support the user privacy and digital identifier system. And also we should have some support, some algorithm for the quantum resistant and something like that. And also we should have the communication network with technical infrastructure to establish multi-party trust. And this slide gives our view on the intelligent and unified network operation to control OPEX. Maybe first we can enable, we have supported the intelligent use the AI method to enable dynamic service provisioning, and to utilize the digital twin and intent-driven network and AI. And also we can get the ubiquitous connectivity management scheme and support a scalable and flexible network deployment. And the previous slides, I just introduced our view on the usage scenario and cases. And also we, in China, we have do some 6G technical trial to promote innovation and to optimize the key technologies. And also we, in our 6G trial, we just to verify the the 6G performance and to verify its how it can support the new services. So I just saw our try items in the left figure. We have do some wireless technology trial, including integrated sensing and communication, wireless AI, RIS, and terahertz communication. And also we have do some trial on the network on service technologies. For example, distributed autonomous network, mobile computing network, and the data service. In the ISAC, we have do many do trial in many scenario and the service model. I just give the example of UAV tracking and sensing assistant communication. And for the wireless AI, we do some trial on the AI receiver with autopilot. And for the system technology, we have do some all-pass data processing scheme in the devices and do the data synchronization trial for the distributed autonomous network, and also do the computing aware function in the to support the mobile computing network. It's a very brief introduction on our 6G trial. Yeah. And now I can go to the second part. First, give our overall consideration on 6G standard roadmap. We think in principle, the first release of 6G standard should meet all the technical performance requirements set by ITU. And also we think we have so many scenario and use cases. So identify key scenario is very crucial. And we think from our point of view, we think the first release of 6G, so the focus on some key scenario, for example, AI and communication, ISAC, industrial IoT, and in addition to immersive communication. And also we think from the spectrum point of view, a 6G standard framework should consider the characteristics of low, mid, and millimeter wave frequency bands. And also we think the licensed access is prioritized. And for the IoT part, considering the long cycle, it is a big difference from our industry. So it may be worthwhile to extend 5G or 5G advanced massive IoT technology to 6G. Some thoughts on 6G system design. The first one is we just want to describe the 6G system capability. We think the 6G system or network will act as a platform to comprehensively enable new services supported by AI, sensing, and computing. And also for the business model, the 6G system design should enrich business opportunities for service provider, for example, by better network compatibility or information exposure, and encouraging more partner cooperation to enable services. And also we think the AI native design should comprehensively improve 6G network performance and support AI services. And also we should consider the balance between complexity and flexibility. For example, the architecture design, configuration, and the options for the 6G system. And for 4G, 5G or 6G, we think we should have less opinion for 5G to 6G migration, and 6G network support working with 5G. And also we should consider integration with some non-3GPP access technologies. Oh, sorry. And for the day one feature list of the day one use cases list, we gave some our beginning thoughts in these slides. First of all, for AI cases, we think day one we should support the distributed and collaborative AI architecture, approaching to the unified framework for AI network and network for AI. And also support the life cycle management and maybe the 5G advanced is a good beginning for the AI for AI, and also to coordination of communication and computing, and support the data collection and data service. For ISAC part, we should support the collaborative sensing modes and support the on-demand sensing and positioning services, and support the AR interface, including waveform, frame structure, and something. For the industry IoT, we think we should identify and support the key features of industry IoT. For example, the HRLC and the RedCap-like solution and the time determinate take transmission and the efficient framework for edge computing. And also from the deployment, we support the distribute and autonomous network, also including the centralized network. And for the emotional communication, we support the multimodal communication, human to X mode, and built-in RTC. And also we support the UE network collaborative processing, and the larger, and also we support the larger basic carrier and multi-carrier from day one. For the NTN, we support in 6G, we support the NTN and the TN interworking, and scalable design for NTN and TN, and also support the satellite sharing. And also support the end-to-end energy saving and energy efficiency schemes, and support the built-in security and trust. So it give very some high-level opinion on the day one use cases list and feature list. So that's all for my presentation. Thanks all.
Thank you very much, Ms. Ying, for your very insightful presentation, especially articulating all the priority use cases and the day one features very clearly. So this is very helpful. Let's go for some questions from the audience. Lena from Vodafone.
Okay, thank you. Hello, very interesting presentation, and I have a question, and it's in the same way than the one I made to India. Apparently, you are talking about IoT that should be extended from 5G to 6G somehow, and what are the plans or the ideas that you have about it? Thank you.
Yeah. I just want to clarify your question. It's about the migration from 5G to 6G. Yes, and we think I think just as the first slide of yesterday, and the GSMA gave the picture of the 5G network in the all the world. We think it was on the SA and NSA deploy mode, and I think in China we have very quick NSA deployment, and we quickly enter the standalone deployment and for 5G, and we think so. Based on the standalone deployment scenario, we can get more capability to support the vertical industry. So we think maybe for the 6G system, we have a new requirement for AI, for ISAC, for the ubiquitous connection. We think maybe they need more new capability from the network side. So we think for 6G, we think anyway we should have the standalone 6G architecture, and we can how to consider the path from 5G to 6G. Waiting from outside, we can consider the 6G interworking with 5G.
Okay, I mean, did you answer the question? Because I understand the question differently. You were more asking about the LPWA, right?
Yeah, more or less. Yeah, but that basically she's saying that, well, if I understood right, it's like you are thinking of a smooth transition, kind of backwards compatibility for IoT devices, right?
Okay, thank you. The questions, Guillaume from MediaTek.
Yes, thank you. On industrial IoT, unless I'm wrong, I think what we heard yesterday from ACIA is that the 5G standard is good enough. There is no market traction, but it's good enough. And I'm getting a bit confused with a few inputs we've seen this morning that basically seem to say that industrial IoT in 5G is not good enough. So what is the what's the actual situation? Thanks.
For the industry IoT, right? Okay. Well, we think we have many experience to use the 5G technology into the factories, and we think maybe the industrial IoT application is not only related to the technology, but also related to many other aspects. For example, the cost, the standardability, also standardability is related to the technology. But we think it's not only limited to the high performance, the low latency, the reliability, or something like that. It is a complex solution, complicated requirement. And also, we think just as talked at yesterday presentation, we think in the factory they want one solution for the whole factory. But in one factory, the applications are diverse. They cover I think they cover the triangle scenarios in one factory. So they need one solution from the provider to solve them a problem. So we think so. So I think the biggest problem is not only related to the high performance, but also for the how to provide the service efficiently, easily, or simply how to meet their data processing policy and something like that. But also we think in the for 6G performance, we think we have some traditional performance metrics, but also we think we have some new parameter or metrics for the sensing and AI. So we think in the 6G time windows, the industrial IoT will include the communication and also include the AI and sensing. So we think it is a mixed scenario or cases.
Okay, thank you. The questions, Giovanni.
Sorry, very noisy. Giovanni Romano from Novamint. The role of satellite, for example, in recovery, resilience, how do you see the role of satellite communication for ensuring very high reliability of the network? Thank you.
You mean for the sharing? Sorry, your question about the sharing?
No, sorry, about the resilience, the recovery in case of earthquake or any problem in the network. So you were talking about the recovery, I don't know if the correct word is resilience, so the capability of the network to recover from disaster and so on. So how do you see the role of satellite in this situation?
Okay. For the satellite part, right? Okay. And maybe give some more information. And till now, we didn't identify some new requirement for the new requirement for this topic. So we just cover the broadband access and the IoT scenario. And also we think in 5G get our big a good starting point for the NTN and TN interworking. So so maybe in the following in the 6G system, we can have some from day one, we can have the more space to design the design the schemes to support NTN, and also for the satellites to the how to use the satellite or NTN network. We think maybe in all the world there are only several satellite system in the air, and also if some country don't have satellite system, but they want to have the satellite service, maybe they have to sharing the satellite system in the air and do something like that. So maybe some information for it. Okay.
Thank you. Other questions? Isobe-san and then Lucas.
Yeah, thank you. At first, thank you for giving a lot of interesting topics. And I have a question on the agile network deployment, customization, and coordination for users. From an operator point of view, we would like to understand the motivation of these topics. So my question, I have two questions. One is, what is a user? Is it for enterprise user or customers? And what is a benefit of value for customers?
Okay, thanks for the question. I think the topic is about the user-centric network. Yes, we think the user include customers and also including the industry industry users. So I think it's not the person or something. It also include some group or something like that. And we thought, and now we think now in 5G we have the network slicing and with NPN or something solution now to support the 2B system, and also we think in 6G maybe we can transfer from the statically in weeks to provide the new services or to meet the new requirement to the dynamic in real time. So we think the now in 5G deployment or application, the factory or the industry requirement is very diversely, and we think but how to meet their requirement quickly or to get the customization sub-network for them. So we think we provide we have some sort of the user-centric network to do that. We think maybe the generality of the user-centric network is different from the network slicing. And network slicing is also just covers the usage scenario part, and we think we should more efficient or more current design for the user from 2B and 2C.
Thank you.
I think we are out of time, but let's take a last question from Luca. Do you still have the question, please?
Thank you, Luca from Inmarsat Viasat. So my question is more on the discussion about standalone, non-standalone. So it seems to me there is different opinions on whether we should do a standalone, non-standalone architecture when moving to 6G. But at the same time, I've heard, and we tend to agree, that the expectation is that we're not going to define a whole new core network architecture, but we are simply going to expand and evolve the 5GC architecture. So my question is, does it make sense to talk about standalone, non-standalone, since we are assuming that the 6G core might just be a extension, evolution of the 5G core?
Okay. And for the standalone and the non-standalone, we think in principle we don't need so many options, just like 4G to 5G. Maybe less less option is the most efficient for from 5G to 6G. It is the first point I want to I want to share. And also for the, we think maybe from the core network, some presentation so that we can do some, we can get 6G core network based on the 5G 5G core network. So I think maybe the core network for 5G to 6G is different for the cases during the 4G to 5G. You know, from the core network point of view, the 4G we introduced SBA in the 5G core network, so the big difference between 4G to 5G. But for the 5G to 6G, maybe a core network will not have so big gap from the device design. So maybe the standalone and non-standalone issue is different for the 6G to the 5G to 6G, and also we think even anyway for the standalone deployment mode, we can get the benefit from the new 6G network design. So we think it is a very high important issue for us to have to deploy standalone network. We think it is similar to our cases in the 5G period. We want to have to utilize the new network capability, the new system capability in our network. So we select the standalone solution. So maybe it's just our beginning discussion, and I think maybe in different region or country have different opinion on these issues. Thank you.
Okay, thank you very much. I think that's all we have for today. Thank you again, and she will be around here, and if you have any further questions, then feel free to talk to her during the breaks. Okay, now we're gonna have a lunch break, and after the lunch break, we're gonna have a presentation from NextG Alliance, and let's come back at 2 o'clock. Thank you. get settled down, please. Can we switch on? Oh, thank you. Let's get settled down, please. And Alan, can we please close the door? Thank you very much. All right, can we also close all the doors in the back and please get inside? All right, before we start, I want to just take an opportunity to thank once again the host for having such a nice lunch available for us. It was so convenient, as well as I think it was really good. I mean, if you agree, then let's give it a round of applause. Thank you. Yeah. And to all my 3GPP colleagues, don't get used to it. I mean, this is not the typical thing, right? So don't expect lunches every meeting, but thank you very much again to the host. Okay, our next speaker is Dr. Amitava Ghosh. And Dr. Amitava is a chair of National 6G Roadmap Working Group in NextG Alliance. And he's also a Nokia Fellow, as well as working on Nokia standard and strategy. So welcome, Dr. Ghosh.
Shall I move the slides?
Is pointer not working? Can we get to the slide on?
Okay, thank you, Puneet. Thank you, Puneet, and good afternoon, everybody. The slides are still not visible here. And glad to be here, and thanks 3GPP SA1 for this excellent workshop. So I'll be presenting on behalf of NGA. The title is NGA Vision for 6G. NGA stands for NextG Alliance. And this is the presentation outline, and hope I'll not put you to sleep with my presentation. Make it as exciting as possible, you see. And although you have seen all the use cases before. So this is, I'll briefly talk about overview, goals and drivers. We have to talk about social and economic needs. Everybody's talking about it. 6G use cases and so on and so forth. So this is the outline of the presentation. And first, I'll talk about NGA's journey to 6G. Now, the NextG Alliance was formed by ATIS in 2020. This is the first time North America has been involved in a G. So North America as an entity was absent from the previous G. All the companies belonging to North America was involved, but North America itself was not involved. So we are very proud that North America is involved in designing a G from the get-go. So we have a broad ecosystem of contributors. We have operators, vendors, hyperscalers, academia, government, and research lab. Around 800 experts with 100+ members. So our goal is to develop North American 6G vision and key foundational documents. We have a key set of research priorities. Our goal is to align with those research priorities. And finally, our goal is to create a 6G public-private partnership for next frontier of innovation. So the NextG Alliance is comprised of full member group, then there is a steering group, then there is a 6 working groups, which includes, I am the chair of the National Roadmap Working Group, Kidong is the chair of the applications group, we have a technology group, we have a spectrum working group, we have societal and economic working group, and overall we have the Green G working group, which is essential for sustainability. So this is first time North America, which includes both US and Canada, involved in a 6G. So our 6G vision So we have a roadmap which defines the path for connecting every stage of the life cycle. So the first thing we did in North America is to target, we call it audacious goals, 6 sets of audacious goals. And that is the framework for our 6G. So it is the 6 set of goals, everybody knows about it. It is trust, security, and resilience, digital world or sustainability. Then we have AI native air interface, distributed cloud and computing. And finally, I can't say it, it is digital world experience. And also we have the other one you see, which is cost efficient solution. Cost efficient. Somehow, as you get old, which you say you lose your eyesight. I forgot to wear my glasses. But anyway, so without this slide. So I am thankful to all the members of NGA who helped us to put together the presentation. So first we look at the societal and economic needs. So from societal and economic needs, we first address the quality of life, and we think 6G will play a vital role in influencing several key areas in the quality of life, which includes education, safety and security, environment, transportation, and so on. The next is the digital equity, and the goal is for 6G to have 100% coverage, right? And one of the ways to do it is using fixed wireless access, which provides a viable alternative to traditional broadband, especially in underserved or unserved areas. So FWA will play a critical role in bridging the digital divide. Then the other important part is privacy and trust. And you see with the trillions of devices for, LPWA and sensors, you somehow need this privacy and trust. And it will be included for a wide range of applications, including telemedicine, autonomous vehicles, smart cities, which leverage the 6G systems. Then finally, why we're doing it? We are doing 6G for the good of the society. So we want economic growth like smart agriculture, immersive employee training, industrial automation, etc. And finally, environmental sustainability is the focus of our Green G working group, and the societal and economic working group will focus on non-environmental sustainability. And so moving to sustainability, you can see on the right side of the figure, it shows the energy consumption per network element. And you can see the trends in energy consumption from 4G and 5G. And you can see the RAN consumes most of the energy. Goal in 5G, we have reduced the energy a little bit. Goal of the 6G is to reduce the energy consumption. With respect to GHG, we want to recycle and waste. We want to reduce the water footprint. And so we should design, as all the other speakers have shown, we should not have sustainability as an afterthought. We should design it from the get-go. Okay. So moving along, this shows that this is the paradigms of sustainability, which is observability, choice, and circular economy. So I'll not spend time on that. The next thing I'll talk about, application that affects all aspects of life and society. This was done by our applications working group, which Keydown chairs. So it is divided into 4 key roles. Everyday living, there was presentation. We have service robot for home assistance, experience, real-time interactive gaming, mixed reality entertainment, critical roles at digital twins and robotics and remote healthcare and societal goals like digital equity and sustainable society. And finally, I think 6G will, it is the foundation for making all these applications a reality. And so next, everybody has seen these usage scenarios for IMT 2030. I will explain it in more detail as we go along. And this shows all the user scenarios are tied to the 6 audacious goals, which is, again, I'll repeat, which is cost-effective solution, distributed cloud and communication, trust and security, AI native, digital world experience, and sustainability. And these are all tied to these user scenarios. You can look at it. So now comes the meat of this presentation. So we started, these are the working groups, and this presentation was contributed, all the contributors are from all these working groups. And so first of all, we have the 4 white papers, which was posted by which was worked by the application working group. Then we discussed the representative use cases. And I will say these use cases are what I will describe is nothing new, but it will be realizable on the first release of 6G, I will say. And then I'll talk about the vertical industry and consumer needs white paper. So initially, there are NGA use case categories, and we divided into 4 categories. And we have a white paper associated with each of these categories. So one is multisensory extended reality, distributed sensing and communication, network-enabled robotics and communication, and personalized user experience. So these are the 4 white papers which lays the foundation for the various use cases, and it is available for everybody to download and read through these white papers. And this was done by applications working group, which Kidong is the chair. Now, there was a lot of discussion within the various entities of NGA. And well, we thought that these are the use cases which can be realizable or will be realizable in the first release of 6G or in the first phase of 6G, which is everybody talked about multisensory extended reality, no problem. Fixed wireless access, ITS, connected vehicles, smart factory, low power wide area, personalized user experience, robots, digital twins, and short range massive sensors. Now you'll say, hey, all this can be realized by 5G, except for every short range massive sensors where ambient IoT still is being standardized. So why do we need 6G? But what we know in 5G, the only use cases which has been realized so far is EMBB and to the extent FWA. All the verticals, I see all the verticals, we talked about it, there are a lot of proof of concepts, but nothing has been deployed extensively so that one can make money out of it, you see. But in the 6G timeframe, it will be realizable where it will generate a revenue stream or it will be the source of making money. So these are not pie in the sky use cases. So these are the use cases which we think will be realizable on, as Puneet says, on day 1 or day 2 of 6G. We had a very important paper or white paper called Roadmap for Vertical Industries. And we looked at 8 verticals, which is agriculture, automotive, education, gaming and entertainment, e-health, industrial, mining, public sector, and smart cities. We talked to the various stakeholders and we found these are the 8 verticals which will change how we live and work, and it will translate North American needs to technology outcome. And what we propose to do is to have, we propose it to NSF to have 5 application research centers to study these applications. And we wanted funding out of it. That is still under discussion, to set out these 5 application research centers based on these verticals and also on the green G. Now, this is the sector landscape for vertical industry. And as you can see, this is based on the research and by talking to the various stakeholders. And you can read, say, automotive. North America is the world's second largest automobile market. And if we can make 5G or 6G or the wireless, cellular wireless pervasive in automotive industry, it will be an achievement. Same with agriculture, like it contributes 6.8 to 7% to the GDP. And if you can automate it and make it wireless based on cellular technologies, it will generate revenue. Industrial IoT, we have been talking about industrial IoT or 4G industry or 5G industry for a long time, but it has not been pervasive. Right? All the manufacturing in US is not totally wireless based on cellular wireless. There are a lot of Wi-Fi based technology for IoT, but in the time frame of 6G, we think there will be more than 10 million to 20 million base stations, and that will generate revenue. So the goal in 6G to make these vertical industries based on cellular wireless, not that it can't be done with 5G technologies, it can be, but in the 6G time frame, we should make these verticals an essential component of cellular industry. So moving along. So we have 9 use cases. So next we'll describe the 9 use cases briefly. So XR, I think the next generation, the smartphone may be replaced by XR headsets, simple headsets or glasses which can do XR. So it is lightweight XR glasses, brain-computer interfaces, lightweight haptics, wearables. The current, all these big headset for VR and all, it is too heavy. You can't keep it in your head for too long. You'll get dizzy, you see. So the goal is to make it lightweight. And what are the North American market needs for XR? You can use XR for education and gaming. You can use for healthcare, entertainment, and sports. And what are the primary 6G potential user experience? We can talk about sensory fusion for enhanced sensations. We can talk about holographic teleportation, etc. You see. So I think now one may ask that why can't you do this using 5G? So you can implement parts of XR using 5G, but can you do holographic teleportation or holodeck using 5G? Probably not. You may do in 6G or 7G, so you can have a holodeck, you see, but we'll implement part of the holodeck, parts of it in 6G. So you have the sensory fusion for it. So what are the key capabilities we need for XR? AI, ML, wide area, we need edge computing for that, precise positioning, and very high data rate. So this can be, this part of it can be done in 5G, no problem, but you'll have the more enhanced experience in 6G. Now, next is the digital twin. So it is a virtual representation of the physical world in the digital world, right? So I think this a digital twin is a virtual representation of a physical object process or system that accurately reflects its real world counterpart in digital form. Now, can you do digital twins in the current 5G technology? Yes, of course you can. Can you do large-scale digital twins of cities or multiple cities or complex industrial? At this point, no, right? But with 6G, you can do it using AI, ML, edge computing, sensor fusion, of course, very high data rate. And of course, we need enhanced privacy and security for this use case. The next use case we have robots and smart factories. So they have coined a term called service robots or sobots or collaborative robots or cobots in smart factories. Now, can we do this with 5G? You can, but you can't do, I have not seen collaborative robots or sobots in smart factories. And for the North America industry needs, it is mainly for industry, healthcare, mining, and sobots for personal care needs, as we saw in various presentations. So what are the key 6G user experience? Enhanced safety measures, enhanced AGVs. AGVs are used in all the factories, and we need to have collision avoidance. All this technology exists, but all the AGVs are currently using Wi-Fi technology. So we want to make widespread use of cellular technologies, which will be realizable in the 6G timeframe. And then for the 6G capabilities, we want to use 6G technologies like AI, ML, precise positioning, low latency, integrated sensing and communication, of course, privacy and security. And then I'll have this ITS and connected vehicles. So AGVs, traffic management system, vehicle-to-vehicle communication, advanced driver assistance systems, and make level 5 driving possible. Is it possible today? Yes, it is possible. But if you look at Tesla, they use mainly sensor technology. They don't use cellular V2X, you see. So the goal is to use cellular V2X, so we have enhanced vehicle to everything communication, intra-vehicle communication, and coverage of the vehicles everywhere. Now, if you drive in North America, if you drive in Wyoming, you will not have any cellular coverage. You see, you may get 2G, maybe 3G, but not 4G. So use of TN and NTN for connected vehicles will be a must going forward, and this can be realized in the 6G timeframe. And next is our personalized user experience. I have 9 minutes. So this is about seamless integrating multiple services with users and environment so that one can enjoy best of the digital world experience. So the needs are healthcare, travel and shopping, education. So if you have an XR glass, you can go to a shopping mall, it will guide towards what you are looking for and guide you to the right shop and the right product you are looking for. So for the 6G capabilities, you are looking at data collection and advanced sensors, wide area cloud computing, and of course, you need AR, VR interface, and all these things require privacy protection. Next use case is fixed wireless access. So fixed wireless access, if you have to provide a digital equity, you want to have 100% broadband coverage. And FWA, although FWA was in 5G using millimeter wave, it was not, the penetration was not that great. And if you look at the right-hand side figure, you can see, if you look at the right-hand side figure, with 2 providers or 1 provider, you can get up to, for 1 gigabits, it is around 24% of the population. The rest is using fiber technology, you see, non-wireless technology. So what are the 6G user experience we need? For FWA, we need uplink data rate and coverage enhancements, because uplink is always a problem. We need enhanced data rate for gaming, immersive communications, and etc. And of course, consistent user experience across urban and rural areas. For that, we need, what are the 6G technologies? Where, of course, we need more bandwidth, we need higher data rates, we need to improve the uplink, because uplink is an issue. We have lower data rates in the uplink, and spectrum sharing and new spectrum in centimeter wave, and of course, the CP performance should improve. The next is, we are looking at low power wide area technologies. Now, why this is important in US? Now, currently, 5G as such has no LPWA, right? It can support LPWA using LTE technology, right? So 5G supports LPWA related use cases only with LTE technologies. Now, when we want to retire LTE at some point, I don't know, 2035, 2040, you need LPWA technologies for all these trillions of sensors, and for EMTC or narrowband IoT, how to have continuity on that. So I think 6G LPWA technologies should be addressed in the first phase of 6G to avoid maintaining legacy LTE systems. And of course, short-range massive sensors. And this is under study. We need this massive sensor using backscatter, so we don't need batteries, especially for agriculture, where we put all these sensors in the field and forget about it, right? And so that cheap sensors using backscatter technologies. Now, this slide is, we didn't want to provide any numerical values for KPI enhancements. So the x-axis represents all the 9 use cases we talked about, and the y-axis represents the various KPIs, which is user data rate, packet latency, positioning accuracy, reliability, connected device per area. And we have 2 additional KPIs for 6G, sensing KPIs, sustainability KPIs, which are yet to be defined. So we said to be studied further. We didn't put any numerical values, but we have put in these circles, which is that user. So for multisensory XR, let me take an example. We want a huge improvement in user data rate. So those are the big circles. So how can you do that? By providing more bandwidth and more, and then we have the packet rate latency. We need more positioning accuracy of, I don't know, less than 10 centimeter or 1 centimeter. So this shows the amount of, the circle shows the amount of improvement in 6G we need compared to 5G. You see, so that's the chart is about. No numerical values, because then it will generate controversy. Why you are saying it is less than 1 centimeter accuracy? Why not it is 1 millimeter? So we want to avoid that at this stage. So this circle shows moderate enhancement, big enhancement, moderate enhancements, and low enhancements. So look at these short-range massive sensors. So the number of connected devices per service area will be huge. That's why you have we need a huge enhancements on connected device per area. So you can look at it at your spare time, and then now this is then what we also did. We had these 9 use cases. Now, how does it map into this IMT usage scenarios? So we divided it into 2 triangles. The left-hand triangle, which is the green triangle, it is the extension of the IMT2030 scenarios, right? So we have immersive communication, hyper reliable communication, massive communication. The right side of the figure are 3 new usage scenarios, which are integrated sensing and communication, AI and communication, ubiquitous connectivity. And the use cases shows where in the triangle it is needed the most, right? So if you look at this blue triangle, and if you look at fixed wireless access, that will help you in ubiquitous connectivity because we want to provide 100% coverage. That's what will help you to provide. So that's how this figure has been drawn, that how are the use cases mapped to these various usage scenarios. So the next, although this is a use case workshop, we thought that what are the technologies which are needed to support these use cases? And again, the dark blue represent essential technologies, the light blue tells you the beneficial technologies, and the light blue says not needed. So there can be more technologies, but we looked at these 8 technologies, which are advanced MIMO, spectrum sharing, upper midband enhancements. So let me talk about upper midband enhancements. So upper midband, in the WRC23, we have the 7 to 15 gigahertz, right? And the goal is to provide more bandwidth, better user experience than C-band, and can it be done? Yes, it can be done because although you have the higher path loss and higher penetration loss, you can compensate that by going to higher antenna arrays and also using higher ARP on the downlink and providing more antennas on the uplink. So these are then positioning JCAS, distributed computing or cloud, and AI/ML. And this gives you that for all these use cases, what are the technologies which are needed most and which are needed moderately and which are not needed. On the bottom are the NGA research priorities. So we have a research council. They came up with 10 research priorities, and you can see it is at the bottom of the chart. So finally, this is my last slide. What are the key considerations for 3GPP? So I will say the key considerations. So we recommended in this presentation use case priorities, technologies, and research actions that are aligned with NGA's vision and North American needs. We talked about sustainability. We talked and identified 8 verticals which will play a key role in 6G North American needs. We identified these 8 or 9 technologies which are relevant to these use cases. So finally, if you look at the success of 6G, we are also collaborating across various regional bodies like 6GIA, Beyond 5G Promotion Council, Korea 6G Forum, Bharat 6G. With 6GIA, we have come with a TTE paper, which has been sent at the ministerial level on what areas we can cooperate. And finally, I think for 6G, what is different from 5G? I'll say 4 areas. We have to invest more on verticals in addition to eMBB and fixed wireless access. We have to design 6G from sustainability in mind, use end-to-end AI/ML, and also what else? So these are the 4 areas where we can focus on 6G, and this is what is different than 5G, and of course integration of terrestrial and non-terrestrial networks. So we have a 3D network rather than a 2D network. That's all. I'm ready for question. Thank you.
All right, thank you very much, Dr. Amitava. So this excellent presentation. Maybe before I open for the question, I'm going to pick up on one of your last theme. You know, the success of 6G will require collaboration across governments, industry, and academia. And I cannot agree more on this last bullet of yours. We have been hearing in the last, yesterday we heard something about, 5G not delivering the promises. So what do you think why 6G will be a success?
Oh, that's a very good question. And why 6G will be a success? Everybody knows the answer, right? Can you guess what I will say? Every event G is a success. Every event G is a success. So that's why 6G will be a success. Okay, go ahead.
But sorry, but this is not what we discussed, right? I mean, during the lunch break, we said I'm going to ask you this question, and you're going to say because it will be done by 3GPP. Okay, so let's start again.
No, 2G and 4G. 4G was done by 3GPP. It was a success, right? It was a great success because of the iPhone. I will say with new devices.
What about Samsung?
And
Nokia
sorry.
had a phone.
No. What I want to say that the LTE specification was the best spec, and I was involved with that, and it was a very great, one of the greatest specification, release 8, and I'm very proud of it.
All right. So I wanted to change the thing because I thought like people coming out of lunch maybe feeling sleepy, so that's why I changed a little bit. So let's now open the floor for the question from the audience. Yes, Scott, please.
LTE, WiMAX, come on. You guys wouldn't have done LTE if we weren't doing WiMAX. He and I were both working at Motorola at the same time doing the opposite technologies. That's why I have to.
WiMAX was a precursor to LTE. Without WiMAX, LTE would not happen.
Thank you. I thank you.
I want to make everybody happy.
Amitabh, thanks for presenting, and NGA for putting this together. It's just a really good job of representing what a lot of us in North America have been talking about, especially the comments about IoT. But one question to you. The U.S. government is getting a lot more active in next generation space in the U.S. In this wireless telco like never before. And there have been statements that they have been making about the importance of O-RAN to 6G and how that provides more security and a better solution. Do you have any comments you can share with us about how NGA sees the role of O-RAN?
So I can tell you NGA has not discussed O-RAN. So I'll raise my hand and say I'll not discuss it because I'm representing NGA. NGA has not discussed O-RAN. So I'll not say anything about it. Thank you.
Okay, that's a smart
See
answer.
how to, I'm like
so before he gets into trouble, he just bailed out, right? All right, so other questions? Yes, please. Smita, right?
Hi. Yeah, I have a quick clarification.
Can you say your name and company so that everybody?
Yes, I'm Samita from Verizon. So slide 22 talks about the massive IoT communication with the devices, scattering devices. Okay.
LPWA, yes.
LPWA, yes. So I wonder, like, backscattering devices are, great because you don't have to change batteries and.
Yeah. So I think the goal is sustainability, right?
Right.
We have to save energy.
Yes,
And,
yes.
She haven't asked the question yet.
So.
What is your question?
I think this is great, but I wonder if we also take care of, like, after a while when we cannot forget about those devices, right? Is there a plan for recycling those devices to maintain sustainability? That was mine.
Oh, okay, very good. So of course there should be recycling. Take the example of agriculture. I have been working on this agriculture. I have become interested in it. So they are saying you have to embed these devices deep into the field, and it is very difficult to recover it, right? So it should be biodegradable. If you have this backscatter based sensors, it should be biodegradable. So we should have sensors which should be biodegradable for the agriculture industry. For the other industry, definitely we want to recycle, because you remember the circular economy and with sustainability, which is very high in our agenda, we have to have provision for recyclability. Thank you.
Okay, thank you.
Thank you. Any other questions? Isma-san?
Thank you. I'm Itsuma from NTT Docomo Japan. Thank you for the presentation. Can you, on page 25, I think you mentioned cloud native. Where and can you, sorry, trying to understand, can you teach me if you meant it was some implications around the core network and RAM virtualization to support those scenarios, or was it more like hosting those applications on the distributed?
I would say both of it, right? For hosting this application, we need edge computing. So we are more at the edge. And also what you said earlier, that is also virtualization is also an important part of it. So I'll say both.
Thank you. So quickly adding, so if there's some implications around the network virtualization part, if you have some insights, what's missing today? We would like.
So as I'm representing NGA, we have not discussed that aspects in detail. So again, I will avoid that question.
Thank you.
Okay, I think we have time for 2 or 3 more questions. So I'll start from the front and then go to the back. Guillaume first and then Jinsuk.
Yes, thank you, Amitabh. That was entertaining presentation. One question on this very slide, AI/ML. I'm not sure I understand what it means in practice. And the reason why I'm asking, I don't see it listed for robotic applications. I don't see it listed for connected vehicles. I would expect AI.
I see. You are right. It should be there. It was an oversight, and AI/ML should be, I'll say, robots, smart fact, ITS connected vehicle. It should be there. So that was an oversight. Thank you. I will correct that this slide. Yes.
Thank you, Jinsuk, LG.
Thank you. I'm Jinsuk from Dish. No. And thank you. I didn't fall asleep at all, and I appreciate about it. And my question go back to the energy consumption. So you give the table. I think I don't remember the page number. So the table show the 5G, the power consumption is.
Oh, I see. I see. This one.
Compared to previous release.
This one.
Yeah, there are table. Yes, but what is the others increased compared to previous?
Oh, what is others? Others means there are other components which are not part of RAN core network.
So
it is a good answer.
I'm okay. So we decreased in our 3GPP domain, but some other area so I think we need to focus on that. Okay, thank you.
Yeah. So I think take the example of data center, right? So in 5G, the consumption went high because for the data, there was additional applications which were power hog. That's why it went up, I think. And the goal of 6G is to put it again down. Yeah, but it is, I'm not a data center expert, but that is the reason. Because you have all these applications which were power hog, that is the energy consumption of the data center went high. Thank you.
So we need some compromised solution for 6G.
Yeah.
Okay. Thank you.
Yes, please. Go ahead.
You mentioned about end-to-end.
Can you say your name and the company, please?
Sorry, yeah. I'm Sandesh from TNO. In one of the slides, you mentioned about end-to-end AI. Sometimes AI is a term that has been used more than what it needs to be used for, but okay. And do you envision a way where there are some components in the device which has AI components which interact with the network components, or what is end-to-end?
Yeah, you are exactly right. So when we have to do the train it, we just can't train the network. We have to train the network, the channel, and the device together. So that's what I meant by.
Yeah, okay, clear, thanks.
Thank you. Maybe the last question. Okay, since I have 2 hands, so I'll give the chance to both. So Sherry, ladies first, and then the gentleman.
For page 25, I'm Sherry Shen from Xiaomi. Page 25, you listed the technologies applied to the use cases.
Yeah, but I carefully read your slides, previous slides, and you listed the integrated sensing and communication for the use cases of robot and for the ITS vehicles. But you, in this table is missing. Did you forget?
For JCAS, right? JCAS for which area? So it is there for everything, right?
So JCAS is the joint sensing.
Integrated sensing and JCAS, they are synonymous. Yes.
Okay, it's a new synonym. I said.
Yes, please.
Yeah.
Last question. Yeah.
Thomas from Fraunhofer. Amitabha, maybe can you give an indication how the NextG Alliance looks at new duplex technologies? Because that's what I don't know if that's under advanced MIMO or spectrum sharing, or where you would position this technology we're just starting to explore in 3GPP.
Full duplex, right?
Yeah, I mean, we started as sub-band full duplex in standardization. But I mean, it's a long way, probably like MIMO for the next 10 years.
Well, we have not discussed in details. I have my own opinions. Can I say my own opinion? Right, okay. So full duplex technology. So what is the maximum improvement you get if you transmit and receive at the same time? 3 dB, right? And then you do the self-interference and outside other cell interference. The maximum you'll get is 1.5 dB out of it, you see. And then you are putting complications in your receivers. So this is my personal opinion. Except for backhaul, I don't think full duplex, I may be wrong, but except for backhaul, full duplex is not that promising, given all the modifications we have to make in UE and so on and so forth. But this has not been discussed in NGA. I don't know in technology working group, but that's.
Sorry, I think we are out of questions and time. So, but thank you very much, Amitabha. Let's give it a round of applause once again. Right. All right. Thank you. And Amitabha will be here. So if you want to talk more and ask his personal opinion or the things which NG is not doing, we'll be very happy to answer those in offline. Yeah. All right, so let's go to our next speaker. So before I invite Dr. Gustav, I have Dr. Colin Wilcox, who's a chair of 6GIA. He would want the floor for saying a few words. So please.
Thank you. Yeah, forgive me for changing the agenda. I just wanted to spend a couple of minutes just providing some context before we go into the real work which Gustav will present. Maybe a short observation on the previous presentation before I go any further. And I did feel that Amitabha showed such political nous in his answering. Really, shouldn't we reconsider the issue of president? Because, I mean, he would be a wonderful new US president. It's probably too late, but I'm just thinking. Okay, the reason for me standing up here is mainly because we've taken a slightly different tack with the presentation for the European region. And rather than having lots of slideware talking about how wonderful the industry association is and how many white papers we've done and this, that, and research project, we've got none of that. We only concentrate on the use cases. I hope that's of interest. It was what the workshop was meant to be about. But just to give you some context, maybe I can just briefly point out the main entities on the European stage for 6G research. So there is the Industry Association, where I'm chairman of the board, the 6GIA. So that's an industry association that has getting on for 400 members from academic, large industry, all the verticals and things like that. And one of the main things we do is we actually run the European level research program together with the European Commission. And the most prominent of that is the Smart Network and Services JU. And within that, we have then a flagship 6G project, which is actually where Gustav is coming from. And a lot of the work he'll be presenting is having a lot of input from that project. But we go beyond that in what we're presenting today. So it's not just about the 70 odd projects within Smart Network and Services JU. Also in Europe, we have so-called national 6G projects. And some of these are quite significant in France, in Germany, in Finland. And what we've tried to do is we've tried to reach out to these national research programs and collate a single set of use cases to bring in here. So that's the landscape. We have the European level research programs, we have the national research programs, and we try to bring that all together. So let me hand over to Gustav, who will talk about more important things.
Thank you. So let me invite Dr. Gustav Willström, who is a Hexa X2 and 6GIA member. Dr. Gustav is working with Ericsson Research Stockholm since 2011, where he has a role of research leader within the radio network domain with a focus on future network technologies, services, and systems. So welcome, Dr. Gustav.
Thank you, Puneet, and thanks. So thanks for the invitation, and thanks, Colin, for stealing a couple of minutes from the free bar. Last out now of the regions, and now you expect to be blown away, I'm sure, with something completely different, something, some pies in the sky. But actually, what I will present now is a coherent European view that we have collected from many partners. And the idea is that the use cases that we present will actually be the ones that will be realized in 6G. So first, an introduction. So as Colin said, we have SNS, which is a framework for research projects in Europe. And we were invited to give this talk on behalf of Europe as a region. And for doing that, we of course invited friends from national initiatives and also other the different SNS projects. So we have Hexa X2, which is the flagship project in SNS, acting as a coordinating product for collecting input and having a sort of a baseline for the use cases. And that was sent out on review to these other products. And we have then worked on it to formulate a coherent European view. So we have done input from 4 different national initiatives, from Germany, Italy, Netherlands here, and France, and then a set of SNS projects. And there is more material. I will now present a summary. There is some more material in the appendix of this presentation. So if you are eager to find out more information, you can simply download the presentation. First, some general 6G considerations from Europe, from SNS. We foresee that 6G provides support for disruptive and high-value applications. We also expect that 6G should contribute to a green transition, support sustainable development goals, and provide innovative business models and be based on innovative business models. All in all, to help society move forward. And importantly, since this is 3GPP in the end, we really foresee a global single standard for 6G. Sustainability is a big question across the world, and I would say especially in Europe. And when it comes to 6G development, we see that it's imperative that 6G works in line with sustainability and towards sustainability. So the critical part is, of course, that we make our networks sustainable themselves. This is the sustainable 6G track, minimizing our footprint. That is the negative impact of our operations. And on top of that, of course, we should study positive induced effects, so-called handprints. And this is often referred to as 6G for sustainability. What positive impact can we have by delivering 6G services in other sectors? Can we help them reduce their footprints? We need to do both. And importantly, we need to look at the so-called triple bottom line of sustainability, not only the environmental one, but also the social sustainability and the economical sustainability. And this is what's depicted here in the figure. We have done an analysis per use case, actually, and this is also available in the appendix if you want to know more. There's this tool being developed called Key Value Indicator, and this is becoming established as a tool set to study sustainability impact, assessing the impact from use cases. And we then urge SA1 to consider using KVIs in relation to use cases and the requirements. So I know that this is already a topic in SA1, and we are all for that. So diving into the use cases now. So we have a view here of 6 use case families. It's 27 use cases, so it's almost twice as many as we started with NGM. And you could say that there is nothing new under the sun, as the saying goes. But I agree with Amitava that, yes, this is true. A lot of this is being studied in 5G. It was already studied in 4G to some extent, maybe in 3G, that was before me. But we believe that this will be realizable in 6G. So we will form a new baseline with 6G, with devices, with network, with the whole ecosystem to really deliver on these use cases, even though they have been talked about before. So they may not always sound that cool, but we believe that this is when it will actually happen. So for each of these 6 families, we have identified a representative use case, and these are the ones I will present. And you can find more details about the other ones in the appendix if you're interested. We can note a few things. I would like to highlight a few things here. One is that we are, compared to 5G, we are moving more into an end-to-end delivery of services in these use cases. It's not only RAN, so it's more than RAN. That's a difference. And these are more than user-centric. So we're actually describing services, the service requirement from a user perspective. And the user may be a business, it may be a consumer. This is actually a mix. So we have some use cases for both these user groups. So this is not about, expanding the spider web 10 times from 5G to 6G. This is actually looking at the needs from a service perspective from that the network needs to provide. So therefore, we more look at the end-to-end service than just the RAN part. So I would say more than RAN. Another aspect that you will see in all these use cases, or in almost all of which should say, is that it's also more than communication. So we are now moving from networks being just communication platforms for being platforms for communication and beyond, right? So we want to do more things, offer a wider range of services from the 6G platforms. Right. And then I should not forget that you see again sustainability at the center of this figure. So this means that all the use cases should provide benefits to sustainability. They should fulfill sustainability requirements. So we should always look at the perspectives of sustainability. So that is one filter that one perspective we should take when we study these use cases. Because in the end, the use cases they're not a pie in the sky, right? But it's a tool for analysis, right? So there's a technical analysis that will be done in 3DPP. There's of course a value proposition analysis that needs to be done by operators and by the whole industry, and to validate these use cases, to make them real and interesting. So we should use these use cases as a tool for moving forward. because in some sense, these are products before we have a market, before we even have factories, right? So some of these will not be realized because maybe we find that for some reason, a sustainability reason or a value proposition reason or technical reasons, these are not realizable. So we are moving now from this visionary part into validation. And of course, we will update SA1 once we have more details on this one. Okay, but now into the different use cases. So immersive experience, this is a use case family which is really about extending the physical reality with digital content. Right, so here we have an example called seamless immersive reality. So you have some sort of head-mounted device through which you can experience digital content just as real as if it was physical content, reality. So the digital reality and the physical reality is seamlessly experienced in these glasses, right? So you can collaborate with people that are distant from you, just as if they were there. You can have remote lectures, experience a classroom, a teacher, and you can really move closer to each other in space. You can also, of course, walk around in cities in wide area scenarios, because immersive collaboration, maybe that's more of a local scenario. You sit inside, perhaps. But this should also be something that you can experience out and about, right? So you go on the town and you experience, for instance, a city tour with digital content pasted on buildings. Maybe you experience Rotterdam as it was in the 1800s, for instance, and it seems real to you. So this is really a consumer use case, primarily, I would say. And this is one that we believe will come early on and will be one important sort of mark of 6G. And then what does it take to deliver this use case? Well, of course, you need a good communication link, but more than communication, you also need AI ML support and compute support in the networks to speed this up, to allow for having slim devices. You need support for sensing and positioning in the network so that you can do spatial mapping of digital content with high precision. You really need to know where the user is and where the user is looking, and you need to know what kind of digital data you should map into the view of the user. Of course, privacy will then be very important. You cannot simply record other people without consent. So this needs to be managed, and here's a real opening for networks. Networks are perfectly placed in order to manage privacy and of course, deliver high security. You need to deliver a good service continuity when you move around in a town, for instance. You cannot have glitches because then the spell is broken, so to say. You don't experience this seamless immersivity anymore. And of course, latency, as you can imagine, needs to be very stable and low. But if you look at the numbers here, and here are some tentative numbers, they are not really extreme in that sense. With proper coding, you would get around with something like 250 megabytes per second. The capacity need can be really high, of course, if you have many people. You can imagine in the street, many people using this streaming services. So something like 20 megabytes per second per square meter. And the end-to-end latency needs to be very robust and low. And note that it's end-to-end. I think that's an important step then from 5G, where we focused a lot on the radio interface. We need to look at the service layer. And then positioning is something that you need in order to deliver this. And of course, there will be onboard sensors, there will be other sensors, and the role of the network is probably to fuse all these sort of sensors platform style and deliver a good and stable precision for positioning. So we need to understand also that we're part of an ecosystem with many other players, cloud players and app players, and we need to find a good role for networks to deliver in. All right, moving on to the next, collaborative robots. This you recognize a lot from 5G. So this is really about supporting an increasing degree of autonomy of robots in factories primarily, than in local scenarios primarily, and in an increasing degree of interworking between different robots, sets of robots, and also between robots and humans. So you want to support this flexible factory where you have humans and robots working side by side. So two different scenarios here is that you have a bunch of robots cooperating to solve a task among themselves. And of course, they need to communicate with each other. They need to communicate with a network. And then they may need to take decisions then. And of course, you need to monitor their activity with a very high precision. You need to know exactly where they are looking, where they are going. You need to plan. So here the network has a big role to fill. And then another scenario is this autonomous agents. So you support robots with intelligence from the network, and you enable them to fully make decisions. So to collaborate with a human being, for instance, the robot needs to know what you're doing, what your intents are, read these intents, interpret them, and take action based on those intents. And this needs to be in real time. So this is very challenging, of course, from the network part. So requirements on the network from this use case relates a lot to this connectivity of the robots, of course. Local connectivity between robots. Also supporting the dynamic topologies. So if you have robots that are working amongst each other, maybe some need to be linked to the network through another robot. So that should be supported, and that should be very flexible and be done in real time, more or less. End-to-end latency needs to be very robust, and of course the reliability also needs to be very high so that you don't lose control of these robots. Positioning again and sensing again, so more than communication. So some data rate figures here are not extreme. I mean, maybe the order of 10 megabit per second. The density, the area density, not extreme either. Mobility also quite moderate. But when it comes to latency and reliability, end to end and not on service level, this needs to be very robust and low. I would say not extremely low. So we have seen numbers of 0.1, and this is more moderate, but still it's end to end, and it needs to work always, right? So here, this places new requirements on the network. But again, I would say that it's not perhaps the RAN requirement that is extreme. It's the more than RAN requirements. It's the more than communication requirements. Then physical awareness. This is more of a, I mean, the previous one was also more a business-to-business case. This is clearly a business-to-business case. This is using the network to sense the environment, using the network to get spatial data of different forms associated with contextual data. So you have some sort of coordinate and you have associated data, or you associate data in the network to those coordinates. And then you use those to use this data to enable different services. So one example use case here that we see coming is network assisted 3D mobility. So using these data points from the network, collected from the data. So note that here, the network is actually the source of the data. So this is something new. It's not just a bit pipe for data produced somewhere else. The network is producing data, using that data to support vehicles of different forms. Drones flying around cities, smart vehicles on the streets, and also giving additional information to, for instance, bikes and cars, so that they know what's coming around the corner, for instance. So this, we have two different cases here. One is what I mentioned, this autonomous drone transport. So supporting the network fully from, supporting the drones fully from the network. So it's autonomous and not from the drone perspective, but from the network perspective. So the network manages the drone. And so this is, you know, a high level of network support. And a lower level of network support is something like assisted vehicles, where you have your electric car moving around in the city, and you have a driver, but you can relax. You may not be needing to control the car always, and you have this side information, what's coming around the corner, where are the bikes around you, where are the people, where do you need to brake. So it's supporting the car from the network with this spatial data that is being produced and processed in the network. So of course you rely a lot on the communication link here, so that's critical. So, and again, it's beyond RAN, it's the end-to-end service that always needs to work. You need to deliver connectivity to these connected vehicles. You need a very high level of service availability. The service should never click, right? So you need different solutions for resilience and reliability in the network. And you need a very good coverage within a city. Maybe you don't need to cover everything, but you need to clearly define the areas you cover, the volumes that you're supposed to cover. And again, sensing and positioning will be key here to produce this data. And you also need to process the data in the network. So you probably need a lot of compute power, and you need a low latency AI model to process this data and to sort of project the trajectories of different things, to detect objects and to understand what these objects are. Is this block here a person? And then you send that process data to vehicles, for instance. So the numbers here are not extreme. If you look at them one by one, taken together, it's challenging, I would say. But this is something we believe can be realizable in 6G. But level by level, you would start at some simpler level, of course. Maybe this assisted vehicle is a first level, and then you move up into more full support of vehicles. Then we have digital twins, of course, about collecting data from many sensors and managing this data. So again, more than communication. So one scenario here, real-time digital twin. So this is very challenging then. You basically update this digital model instantaneously, and you use it to steer functionality. So you have sensors and actuators, many of them connected, and you use them to get an instant view of your operations, and you apply intelligence in the network, and you control your operations. So for instance, a production plant would be connected, or so that would be a more local scenario, but it could also be a more wide area scenario, like a smart city, where you have some community connecting all their activities like public transport. And for this, again, digital twins can mean many things. It could be a non-real-time digital twin. This is the more extreme case of a real-time case. And here, end-to-end latency will be important. The coverage will be important also within your defined service area, and the interoperability will be important because you connect things in factories, things in cities, and that needs to be working very smoothly, and it cannot be a sort of a difficult integration of 6G into the different ecosystems. This we have seen is a problem in 5G, that the integration into external ecosystem has been slow. Very high reliability in this case, very high precision when it comes to location and sensing. This is more of an extreme case. Also the low latency combined with these other requirements makes it quite challenging. A fully connected world, this is really about providing digitalization and the benefits that come with digitalization to everyone. So wireless internet access everywhere, to everyone, everywhere. So here you can connect remote locations. So people living in places where there is currently no network coverage. Of course, this is something that we want to fix. You can fix it by a combination of fixed wireless access, like Amitabha was talking about. You could have these high tower, high power kind of base stations, use existing TV base stations covering maybe up to 100 kilometers. But also you need satellites for this. You need to integrate the satellites into the 6G network. So you create a platform consisting of many different types of accesses, all connected in a 6G platform, or another way of saying it, you put it on the 6G umbrella. So you have satellites that you would smoothly go to without losing service continuity when you move out of a city. And when you move inside, you would switch to an indoor system like Wi-Fi, again, without losing service continuity. So this is sort of a vision for how things would work. And important here is also a resilient network. So during natural disasters, which we have seen many more of recently, we know that society relies to a very high degree on networks, right? So they cannot fail. Whether we like it or not, we have to provide network connectivity everywhere at all times. And then having sort of different systems that could take over when one system fails becomes very important. So you have some sort of end-to-end fallback solution would be very important. So here, connectivity everywhere is the ultimate requirement. And resilience becomes very important because in the end, if people rely on networks, they cannot fail, as I said. Flexibility probably needs to be, it's probably necessary. It's not a goal in itself, I would say, but it's necessary in order to deliver connectivity everywhere in a cost-efficient way. You would have a range of different access solutions to work with. And you have to sort of fix your network connectivity using these different tools, like a Swiss Army knife. Service continuity, as I said, across the different topologies. I think this is a differentiator between 5G and 6G, where 6G can really make a big difference. And affordability, like many speakers have raised, especially from India today, is important. I mean, if we intend really to close the digital gap, we need to also be able to provide simpler services, more baseline services. It's about basic mobile broadband delivery, but delivery everywhere and to everyone. So maybe supporting feature phones also in a cost-efficient ways everywhere. That is something which 6G should target. So 6G needs to provide this very wide range of services to a wide range of devices, to a wide range of areas. Quite challenging, of course, but this is something that we can set out to do. So within one network, so having multiple goals and multiple services within one network. That's the new thing. Finally, then, trusted environments. This is about local use cases that are human-centric and that are very important to us as people. So life close services, you could say. So for instance, relating to healthcare, can we trust networks enough to connect different smart e-health equipment to provide medical services for us, doing monitoring, diagnosis, treatment? This is important, right? And this is something that the 6G network could deliver, since we probably will have the trust of the people to deliver these networks, these services. We can also deliver safe environment information. So providing this contextual information on what's going on in an area to an individual. So again, this is a consumer use case. So this is services that a consumer would get. So information about, am I safe now? What should the safe way be? This is data that the network can collect and process and offer as a service. And also provide services on public safety during big events. For instance, tracking where floods of people are going when they exit a stadium, and predict where there will be problems and act based on those predictions. So using the intelligence in the network and using data collected from the network. Of course, this is sensitive and you need to handle the privacy properly, and you need to manage all this data in a really safe way. The privacy and security is the most important requirement here, and the reliability also. If you really rely on the system for your health, the system cannot fail. And you will need to use compute and AI support from the networks to deliver these kind of services. You also, again, need more than communication. You need positioning, you need sensing, and you need to be able to identify people primarily using the network and what these people are doing. So you need to do some sort of prediction. You need to have a model of where people are going, for instance, and you need to be able to use that model in order to provide services. So not super demanding in terms of KPIs, but it's more on this functional requirements and privacy especially. Can we deliver the high trust that these services demand from the public? Okay, so that was the set of use cases, and again, you can find more details in the appendix. Finally, I would just close with some operational aspects. So this is not necessarily connected to the use cases, but there are still aspects that are important to the stakeholders, to the industry, to you guys, and also in some extent to the ecosystem partners. So how do we build networks and how do we offer these services? So there are some things here. On spectrum, for instance, this has been discussed already many times today. We see that 6G should be deployable in 5G bands. This is making everything much easier. Spectrum sharing should be there to make a smooth transition possible from 5G. And 6G should be able to use all available frequency bands. This is to deliver robust connectivity everywhere. A unified interface is important. So you should be able to connect any type of device to the network. This should not be a complicated thing. And this is what has, to some extent, stopped the 5G development, because it has become too complicated to integrate 5G into external ecosystems. So there should be predefined interfaces between the communication service providers, the cloud service providers, and the app service providers. So this API first thinking is something we should deliver. And this, I think, can be partly delivered from 3GPP. And then an intent-based management will also be important, and defining this in a clear way so that different stakeholders can communicate through intents. And then what I talked about before, this network of network aspects. So there should be one standard providing these multiple requirements, delivering on these multiple requirements. So we should have an end-to-end network integrated in the terrestrial network, and these should be converged. So under the 6G umbrella, you should be able to provide different types of services on small scales and on large scale. And the deployment should be simplified, and the management should be simplified. This is something what we hear a lot from the operators. Again, the smooth migration from 5G and mobility between 5G and 6G. And then I think picking up on one thing that was mentioned, I think by T-Mobile, I mean, having full functionality in 6G will be important. Otherwise, you rely a lot on previous releases, previous generations. So there should be a high level of feature parity, then supporting voice, SMS even, and supporting the most important use cases from earlier generations. Not necessarily everything. We should also clean up and simplify. But that will be important to sort of make a full release. So 6G, the first day 6G should be a full release offering all the services that is needed. And then we should, of course, provide support for new services. So and there should be exposure of these new capabilities, this more than communication, beyond communication services from a 6G platform to support these new services. And yeah, compute and AI should be among those services that are offered. So I think that closes my presentation. Thanks a lot for your attention. Please reach out if you have any questions, and we can take some questions now.
Thank you. Thank you very much, Dr. Gustav, for your excellent presentation. Very robust set of use cases, right? So do you think all of them can be done in first release of 6G, or how long do you think we have?
That is a difficult question. I think, I mean, the one I presented today are the one that we have prioritized. And I think they can be done on different levels, as I explained. So maybe all of them should be delivered on some level in a first release of 6G, because these are things that we have sort of picked up from the markets, from the industries. So these are things that would be interesting to deliver. But as I said also in the presentation, that we are now in the process of validation. So we look at these use cases then from the viewpoint of technical realization. Can it be done? Is it reasonable to do it? And then from a value proposition perspective, is it sort of, will it solve problems for stakeholders? Will it be sort of economically interesting? Will the operators care about them in the end? And will the market care about them in the end? And then from a sustainability perspective, is this beneficial in the end? Or is it clearly non-beneficial? So we do this analysis, and once we have done that, I think we would know more. And then maybe some will be thrown out, and maybe we will add some. I expect that they will be modified, and maybe we will identify that from a technical perspective, it's not reasonable to deliver the full service day one. Maybe we would instead deliver sort of a partial service, a level 1 of this service, or compared to 5G, maybe it's a level 3. I mean, if you look at XR, this is already specified, and you could say it's an exponentially slowly growing market, right? That's maybe level 1, and in 60 day 1, maybe we will reach level 3, and then maybe later on, day 2, we will reach level 5.
So do you have like a time frame when you think those analysis will be done? I mean, the reason I ask is, 3GPP has its own 6G timeline. So what we need to make sure that your analysis kind of precedes that, so that that can feed into the work in 3GPP.
Yeah, you will have this workshop again in 1 year, right? Then we will be done.
That would be not on the use cases. It will be more about the architecture and the studies which will proceed into the downstream group. By that time, SA1 would have made quite a bit of a progress. So the earlier is the better. I mean, if you tell us that maybe 1.5 years, 2 years down the line, maybe the boat has missed. So maybe something you take into consideration when you discuss this back into SNS. Okay, thank you. So let's open the floor for questions and answers. I'll go from the back, the gentleman over there. Yes, please. I think it's not working. Not yet, but I can maybe switch the different one.
What about now?
Yeah, okay. Perfect.
Thank you. First of all, thank you for the neat presentation. So my name is Moteza from 6G Innovation Center in UK. So I think in slide 12, you mentioned regarding 6G side link. So I wonder, how do you see it, in terms of comparing with 5G side link? So do you see its evolution on radio protocol stack at a frequency that they operate, integration with sensing? So how do you see 6G side link?
I believe there will be a 6G side link, and hopefully it will be more of a success than in 5G. But I think the alternative is worse, right? So the alternative would be that the local connectivity between robots, for instance, is done on some other protocol, right? Some other standard. That would be not good, right? We want to keep it under the 6G umbrella, right? So in the network of network vision, right? So also this local connectivity should be supported, and it should be secure, just like all the other levels.
So you mean that we might not have like an extra feature on side link because existing 5G side link provide that, right?
Maybe it does. I wouldn't dare to venture into details there.
Thank you.
Yeah, other questions? Ian, it is.
Thank you. Ian Sharp from Attis. Thank you for the clear explanation of the use cases. One thing that struck me listening to this was the number of use cases that depend on end-to-end guarantees for various parameters, and something that was covered in a lot of other presentations as well. I mean, generally for most users, most of the time today, 4G and 5G are providing access to this thing we call the internet, which provides basically no guarantees on latency, reliability, and so on. So is the conclusion of this that really a defining difference with 6G is also not just the enhancements to the radio interface, but also the creation of a new kind of backbone that can actually deliver these end-to-end guarantees between different devices, potentially in different continents or different networks? Thank you.
It is a good question. I mean, we cannot take responsibility for the whole of the internet from the network perspective. But if we take the perspective of the application, they don't care, of course. They don't care what is the wireless part and what is the wired part. They don't understand this. It's not of their, it's not interesting to them. So they just want to see that the service is delivered, that it corresponds to some service level agreement. And I think in these service level agreements, we have to take the whole latency into account somehow. And maybe that's has to be done by having some sort of high buffer then to take the potentially high latency into account from the internet domain. That's, I think, the best answer I can give now. But it's a challenging question, of course. Who knows what can happen sort of outside your own domain? Anything can happen. But also you have the strength of the internet in the sense that it has an internet structure. So if there's one path not working, you can always route it. So you can probably always get your packet through. Can you sort of do it with a deterministic latency? That's the challenge.
Thank you. So I think I'll take two more questions and go a little bit over time. Let's look at the space who are not yet able to get anything. So yes, sir, please. Can you introduce yourself, please?
Hello, Dimitri Ionescu, Charter Communications. Dimitri Ionescu, Charter Communications.
Speak up, please.
I didn't hear much during the presentation, both in this European part or the North American, about the so-called NR unlicensed, the unlicensed component of 5G. And I'm just wondering if it was just an omission or deliberate leaving it out.
I mean, coming back to what Colin said, this is a workshop on use cases. So we are not discussing technical components. So I didn't actually talk much about technical components in my talk, more about functional requirements. And of course, if unlicensed helps you deliver full connectivity, high rates, cheap access, etc., that will be of value. But today, I don't think we are discussing the individual technical components.
Thank you. Okay, so we have one last question. Who has a really good question? Amitawa? Okay. Hold on, just getting the mic.
I have one simple question that what additional KPIs and KVIs you are doing or you have defined for 6G? I understand like sensing range, it was not there in. So have you defined the numerical values for sensing range or KVIs for sustainability? Thank you.
So that's two different questions, right?
In what are the additional KPIs and KVIs for 6G? That's the basic question.
So a KPI for sensing, was that the first question?
Yeah, well,
Okay,
sensing
so that's
is one of the features.
quite concrete. We can talk about that. Yeah, so I mean, detection probability, for instance, is one KPI that has been discussed. I mean, if you rely on the sensing from the network to detect people, you want high reliability in detecting people. You don't need to know exactly where they are or how big they are, right? But you need to know it's a person and you need to detect it, right? So that's something that is of interest. And then, of course, you can dive into various. The important thing is we should think about what do we want to do with this sensing. I mean, we want to detect objects in a sense. And then I think it's interesting to understand how big objects we can detect and at what distance and with what probability. So KPIs relating to those sort of capabilities, I think.
And then you defined it already, so that's the question.
Sorry?
Have you already defined it?
Yeah, we have a sort of a draft set of KPIs I mean, maybe not, we have not specified the numbers, but we have proposals for KPIs from HexX2, for instance. You can find it in our latest deliverable. Yeah, in line with what I said. And then you asked about KVIs, so that's a very different question.
Sustainability, yeah.
Yes.
Okay, so maybe this can continue during the break. Before we go for the break, I want to take an opportunity to thank three members here. You know, you see the three members which is running around with the microphones. They are not employed by hotel. They are not getting paid for this, but they've been really generous at 3GPP members. So Prachi and gentleman, I forgot your names. Sandesh. And Nasima, right? So three, can we have a round of applause for this? Thank you very much for your help. So let's take a break now. After the break, if you can basically show the next slide, please, for the agenda. So we're gonna have a panel on building a global 6G view starting at 4. So please, let's come back at 4. Thank you.
Check. Sir.
Nee, maar het kan wel ietsje harder. Ja, oh, die heb ik toch niet nodig, joh.
Hey. Ja. 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 Yeah, yeah. Yeah. Hey. Yeah.
Yeah, he got a like.
Yeah. Hey. Yeah. So.
And the data center is
That was a question. No, I totally.
Okay. All right. Can you hear me? Okay, good. Can we please close the door and start basically settling down? Okay, we're gonna start the panel, folks. Can we please take our seats? All right, so this is a panel number 3 on building a global 6G view, and we have esteemed panelist. This would be moderated by myself. My name is Puneet Jain. I'm 3GPP chair. So let me invite first Dr. Satoshi Konoshi. He's basically, as we saw him in the morning session, he's a head of technology leadership at the KDDI Research and also from Beyond 5G promotion groups. Next one, we have Dr. Nem Sakko from Korea 6G Forum, and we also listened to him in this morning. Next, we have Dr. Xiaofang Liu from IMT2030 promotion group. Okay. So Dr. Xiaofang Liu is a Deputy Chief Engineer from CICT and 3GPP Chief Delegates of CICT. He is also serving as a chair of IMT2020 5G promotion groups, 5G plus AI work group. Unfortunately, we do not have Mr. Rajesh Pathak, who we heard from Bharat 6G Alliance. Because of his remote, we do not have a facility to have him remotely join the panel. So next one here, Dr. Kidong Lee from ATIS NextG Alliance. He is a chair of application working group in NextG Alliance, representing LG Electronics, USA R&D. He serves as a 3GPP V2X rapporteur, as a work stream chair for NGMN Alliance on V2X task force, as well as has been a 3GPP SA vice chairman previously. Last but not the least, we have Dr. Gustav Wilstrom. We also just heard him before the panel. Okay, please. Okay, so thank you, gentlemen, for having the part of this panel. What we saw is that, through the various presentation, right? So what we have been seeing quite a bit of commonalities on the 6G use cases. So are there any regional specific use cases that anyone would like to talk about? I mean, the use cases that are specific to that region that needs to be addressed in the first release of 6G specification developments. So let me start with you, Dr. Nemtsov.
Thank you. I guess I already explained in my presentation. So in Korea, and I guess it will be very similar in Japan. So we are entering very rapidly into super aged society. So that's why we wanna solve that issue as the first day one use case. Even though I said it'll take some time before we finally realize the full capability of elderly care service, but we see the elderly care service as the day one use case that you wanna see in Korea.
Okay, so this is something which you see as the importance to be handled in the first release of.
Yeah, so as a capability, I also mentioned about the network sensing to monitor health and behavior status of the elderly. And also maybe AI and global mobility can also help the elderly care services.
Okay, thank you, Dr. Satoshi.
Yes, thank you. Yes, as in previous speakers mentioned, well, Japan is one of the aging society, as I said during my presentation, and that's why robots as well as other mechanics are highly demanded by the industries, so that from the viewpoint of networks or network operators, we better to provide a good networks with stable and reliable and a guaranteed one.
Thank you. Okay, so Dr. Gustav, from EU perspective, what do you see a region-specific use case?
Yeah, maybe not a use case as such, but more a requirement on use cases. So I highlighted already sustainability. So we really push from Europe that use cases should be validated from a sustainability perspective. So we can use KVIs as one way of validating, analyzing use cases, and sort of to check that they are okay from a sustainability perspective. So this is a priority from the European point of view.
Dr. Kidong, from Next Alliance, what do you see the regional?
Yeah, thank you. So as presented by Amitabha, so US is one of the largest food export country, and as well as the automotive manufacturing country. So in that context, we have a couple of verticals industry related to this topic. So out of the use case, if we have to choose only one, I think it's quite difficult decision to make. But out of them, among them, we are working on to down select three candidates, day one item, which includes LPWA, fixed wireless access, and ITS and connected vehicle. So I believe if we have to choose only one, maybe one of those three candidates item would be the answer. But I don't have any clear answer for from the NGA perspective because we did not make any clear decision yet.
Okay, so this is a common theme as Amitabha. You cannot speak for NGA. All right. Okay, so Dr. Fang.
Okay, thank you, Puni. And I think from the point of view, I'm 2030, and it's quite high level focus because at this stage we are more focused on the AI part and also the sound sensing, and see also important for IoT in addition to the commercial communication. Maybe in the later stage we will have more special use cases for AI or detail things, and right now I think that only focus on that level.
But do you see them as being a global application, or is there anything China specific there? Is a region specific aspects which I'm very interested to understand?
Actually, no. It's really pity.
Okay, so maybe I wanna just push it a little bit harder on this question. Like, if 6G can support only one use case for 6G, so only one use case, what would be that use case from your alliance perspective? So, Dr. Gustav, first, only one use case which can be supported by 3GPP in their first release. What would you pick?
So now is when I can pick three, because not everyone is doing that. No, I think the emblematic use case of 6G, I think, will be immersive communication or mixed reality. I think this would be the consumer-focused use case that would get the most attention. So that's the one that I would pick.
Okay, yep. Dr. Nemtsov, from your one use case.
Yeah, I think it will be very similar to the previous speaker. So I also think hyper-realistic metaverse service that require higher bandwidth and also low real-time and lower latency requirement.
Okay, thank you, Dr. Srafang. One, not three.
Yeah, and the only thing maybe I want to highlight is the network for AI part, including maybe the AI the network work can provide some services to the different guys for maybe for training and also for inference, and that's the really important new applications. And I think I would like to highlight. Yeah.
Okay, thank you. Yes, Dr. Satoshi, what do you have the priority use case number one?
Well, it is not a use case, but what I want to emphasize that guaranteed network would be one of the good solution that is applicable to multiple use cases.
But you can do that with 5G. Why do you need 6G for guaranteed network?
If we can do that in 5G, but 5G is okay, but I don't think 5G is not so reliable compared to the requirements from the various industries. As a matter of fact, that's why they are seeking more high demands to telecom industries.
I mean, if I might just push further on that, why would you need a new radio interface for a guaranteed network? So do you see like 6G being just about, so what would be the radio aspects here?
Okay. Well, yeah, as Puneet said, well, there is fluctuations, especially in the RAN side, radio access network side, especially in a server network. We have server edge areas, so that the throughput deterioration is pretty high compared to a cell center area. So we're better to have a new mechanism or feature to mitigate cell edge throughput degradation. That is one of the key features towards the 6G era.
Okay, thank you. Okay, so as we know that the regional research alliances has been spent quite, I mean, I said at least 2 years, right? I mean, in your organization, maybe more, right? Looking at the 6G use cases, the KPIs, but you have also, I understand, is looking at the technology areas, right? So what are the technologies of future that can address some of those use cases? So my next question will be, are there any particular technological breakthrough or innovations that your alliance is focusing to meet the 6G use cases? So let me start with you, Dr. Satoshi.
Okay, again, the distributed MIMO or something like that, or free massive MIMO may be able to mitigate the cell edge interface mitigation, so that we may be able to stable radio access network performances in the 6G era.
Okay, thank you, distributed MIMO. So Dr. Gustav, what about you? What would be the technological breakthrough and innovation that your alliance would focusing on meet the 6G use case?
And I can pick one.
Mm-hmm.
Yeah. So we have, I mean, explored a very wide range of technologies. I would say perhaps that I have to point at the use of AI in networks and for services through the network as the one with the highest wow factor, perhaps. Will it be the most important component of networks? Probably not, but maybe it will be the biggest delta towards what we have now.
Okay, thank you. So Dr. Xiaofeng, you.
Yes, thank you. And I think I also highlight one part of AI, but another part maybe the AI for network, and I would like to highlight for the next 60 design, because it conclude at least for wireless AI and AIF based and receiving, and also some network automation. And I think all these parts have the potential to trigger the totally new design for the new 6G networks. And I think that's maybe the first priority, and then maybe also sensing should play an important role for the next generation design, because we can see that sensing for many use cases, just like maybe digital twins, and also trackings and other use cases should use sensing, and then it's also very important for the design. In addition to that, I also think that the traditional telecommunication technology, just like MIMO, also just like and receiving, and maybe full duplex, maybe avatar. We are very happy to do that, and all these things will contribute a lot for the technology and the whole design for the 6G network. Thank you.
Thank you. And Dr. Kidong, I mean, don't say that NG has not discussed it.
Oh, yes.
So again, what would be the technological breakthrough innovation that you have looked in the Next G Alliance, which you think would meet the 6G use cases?
Yes, for day one. There are many interesting aspects, even you know, the possibility of commercialization. But if we let that alone, let that aspect alone, then I think we in technology working group we have discussed. You know, as you remember the presentation from Amitabha, we have many aspects about throughput enhancement, and also some new fancy feature of sensing. So in that context, I can say extensive MIMO or advanced MIMO, and also sensing aspects are going to be important aspect. But if we say something about enabler, then I think in the context of data collection by massive sensor, we can say the support of fixed wireless access and LPWA might be some very feasible and promising candidate enabler for 6G system for day one.
Okay, thank you. So Dr. Namsok from Korea perspective, right? So what do you see?
Yep, because I picked, hyper-realistic metaverse as a day one use case. So we need the technologies to increase bandwidth and also latency, end-to-end latency. So in radio side, extreme MIMO technologies, and also because we also heard a lot about end-to-end. End-to-end means it also include the wide network as well. So we see 6G just not as a radio network, radio access network, but also it includes other parts like end-to-end means other wide network parts. So we also are working on the performance guarantee technologies end-to-end, including wide network part. So yeah, performance guarantee technologies as well. And also, I guess it's not, it may not be easy to include that in the initial release of 6G, but we are also working on kind of revolutionary issues like RAN core convergence issues. So we wanna integrate some part of radio technologies into core or core part to radio part. So we are working on that as well.
Yeah, thank you. So I want to check if there are any questions from the audience. Okay, too many hands. So just please, sir, please can you, I know you're from China Mobile. I'm sorry.
Yeah, I should apologize. I'm not anymore working for China Mobile.
Oh, I'm sorry.
Yes, I work for Huawei now. So
okay.
Can I ask panelists, because you mentioned about immersive communications, are you talking about the operators to run this kind of business, or are you talking about you are supporting hyperscaler to run this kind of immersive communications?
So who would want to take that? So yes, Gustav, please.
I think the network should offer APIs to enable these services. So there would be APIs for the communication link, APIs for the localization, APIs for AI support, compute support. And then I think the natural setup is that an application service provider accesses those APIs and offers the service to the end consumer. So it will be a business to business to consumer use case. Then of course the operator can do it, but who would write the application? Someone needs to write the application and then offer the service, and the application needs to use these APIs.
So you do not think operator has a confidence to run those applications? So that's,
I mean, looking at what we have now, right? Operators are not writing games and creating movies, right? So there are other players, content creators that do this, right?
Do you think IMS has a future? I mean, that IMS has a future to support such kind of immersive applications?
IMS, okay. I mean, I'm not sure if you missed that. Somebody was asking with non-IMS based voice, right? So I think that was this.
That's a scarce.
Yeah.
I mean,
I don't know. Aren't we sunsetting? Someone said.
Okay. Does anybody wants to comment? Anything additional?
All right. Thank you. No problem.
Thank you very much. Any other questions? Guillaume, please, and then Zukong.
Yes, thank you. So in many of the stories we've heard so far, AI/ML is more or less central to every single use case, every single technology. However, AI/ML, which is fairly new as feasible technology, is totally unregulated today. And I would like to understand, or maybe if you could shed a bit of some light on your different regions on the status of regulations for AI/ML and how this could impact, in fact, the development and use of AI/ML in 6G. So, I mean, one example could be how do we ensure AI/ML can follow the EU GDPR regulation, for example? How do we ensure AI/ML will be secure, that meaning you cannot pollute with wrong data, the model training? And how do you ensure you can trust eventually AI/ML and the use of 6G? Thanks.
So Gustavo, you want to take that? EU is usually ahead of all the regulations, right?
Sure. I think regulation will be very important in the future, more important than today, not only when it comes to AI. So in general, when it comes to privacy, data usage, I think that will be very important. And from a telco perspective, this is both a challenge and a great opportunity, because I think we have to realize that we have a very high trust in the telco system. So we can probably be managers of data, of AI with a high trust. And maybe, I mean, I think there's a lot of skills in the community on how to handle regulations. This is what operators do to a very large extent. They handle and adhere to regulations. So I think they should be perfect in a sense to also handle, manage AI regulations within their networks. And on details, I wouldn't dare to say much on, on the regulations. Maybe someone else. Yes, please.
And thank you for Georg's question. And I think we are really at the very initial stage to integrate AI and also the 5G or 6G network. We are still discussing a lot about how to design the next generation network, or not only for our interface, but also for the hardware, also for the whole architecture. And I think that after we have some initial conclusions, or some common understanding, and we can promote some more conclusions from the fourth government. And the government cannot give any guidance before the really use of technical. So there's a process of study and then maybe proposal, and just like a circle, and we cannot simply say right now we should provide just a simple guidance or such things, and then we should follow. I think at this stage we cannot get that conclusion. Yes.
So maybe if I can extend the question from Guillaume a little bit, right? So in generic term, I mean, not just for AI, what is the role regulators are playing as part of your research alliance? So are you having a constant feedback through them, or is it something not involved at this point of time? Or you want to talk about that, Dr. Satoshi?
Well, as a matter of fact, we haven't yet talked with details with our Ministry of Internal Affairs and Communication, MIC of Japan. But yes, I think we have to come up with a new idea how to handle that kind of issues and how to fully utilize AI technologies. So Japan has been discussing AI principles, so-called AI principles, and Japanese government tried to coordinate with neighbor countries or rated countries to have a better AI principles in the near future, as far as I understand. So in line with the kind of AI principles, I think not only vendors but also operators like us have to fully align with that kind of AI principles, even inside of AI network technologies and systems.
Thank you. So Dr. Chipsong, please.
I don't have any specific information on that, but as far as I know, our government also has just started to look into the privacy issues in AI, and also they just follow the status in especially EU, because EU is a little, faster than other parts of the world in the privacy issues. So we just started to look into the issues in the government.
So, Kidong, do you want to add something?
Thank you. So we have two aspects. One is about the regulatory requirements. So in NGA, we have some initial, topic shared that is about how AI can do something like a human who has ethics in the way they make decision. And if I can continue that aspect onto some cyber physical system, that's also something about the robot ethics that has autonomous decision-making feature. And also so not only for ethics, but also we have in NGA, we have a policy committee, which is acting as a gateway between NGA organization and the external like government or whatever. So we have some mechanism to have some interaction. For example, something about AI Accountability Act or something. So that part we have not have interaction so far, but definitely so that we can make it happen in the 6G market, we definitely have some feedback when we develop something.
Okay, thank you. So Zukang, please.
Yes, thank you. This is Zukang from Huawei. So I think in the next few years, it's very important for the industry to build a global 6G view. But at the same time, continue to improve the 5G commercial success is also very important. So my question is, what actions should our industry take in the next few years for both 5G and 6G, and particularly from your region perspective? Thank you.
Okay, who would like to?
Okay, let me start.
Yes, please.
Yeah, thank you very much for your question. Well, definitely we have to seek both simultaneously because we have started 5G deployment from 2020 in Japan, and we are still in the middle of the final goal. So, well, as a matter of fact, standalone systems have not yet fully covered in entire Japan. So, well, in order to enjoy the full capability of 5G, we need to think about to deploy SA as soon as possible. But at the same time, we have to, well, seek a possibility to monetizing using SA architecture. Otherwise, it's a chicken and egg problem, but well, it's for sure that we have to monetize that using SA network toward 5G deployment as well as 6G investment. And as for 6G, well, due to the fact that 5G may not be enough from a viewpoint of vertical industries, then we have to come up with new ideas to overcome the issues together inside of 3GPP and other standardization bodies. And then, yes, we have to prepare to deploy that kind of new systems, maybe 6G, as soon as possible to provide good solutions to the vertical industries.
Anybody else? Gustav, please.
Yeah, I really agree with Satoshi-san that SA will be very important to deploy. I mean, as we saw here in the use case presentations, many of the 6G use cases are evolutions of 5G use cases, and it's really important that that market becomes established, that we see a ramp up of these new services, these new ecosystems already with 5G standalone, so that when 6G comes, the markets are prepared, there is a demand already. I think that will be key for the success of 6G. So standalone first, of course, and establish the use cases and then expand on them in 6G. That will be important.
Anybody else would like to add something? Hidong, please.
Yes. So let me try to approach from the perspective of process. So in NGA, we are trying to collect various type of view from three categories of members: operators and vendors and hyperscaler and others, so that we can. So we should have. It's clear that everyone agrees that we have some learning point. So in the context of losing something or making it happen in 5G market or something. So we carefully try to collect various type of views so that we can minimize the variance, the risk in the coming market. And also in the context of 6G preparation, we also try to not really focus on the revolutionary aspect, but we carefully try to identify what real, what actual gap we might have and what the gap might imply for making those aspects into commercialization. So that's how we try to put our effort on. Yeah. Thank you.
Thank you, Xiaofeng.
Yes, I think right now China has already have pay high attention for the develop and the commercialize for 5G Advanced, and we think that if you look at the specification for 5G Advanced in release 18 and also in release 19, we can see that there's many features such like network energy saving, memory enhancement, and also some important features that ambient IoT we can deploy quickly and meet the quick requirements for the operators, also maybe from the market. And then it's really important for deploy that features as fast as possible. And maybe this and some other features like AI or sensing part also maybe also for the duplex. And I think it's more related to the 6G. And then I think that 5G Advanced may be the fundamental thing for the whole sustainability for the whole 3BP society, not only for 6G only. And I think so it's more important to focus on 5G Advanced. First, it's important because there's a gap between the commercial deployment between the 5G and also 6G.
Yeah. Do you want to add something, Dr. Namsuk?
Yeah, so in Korea, I guess I already explained in my presentation, we balancing two. We also expand 5G into particular industries, and I mean at the same time we also focusing on 6G revolutionary approaches. So balancing is also important. So we have to also do some effort on 5G as well. Thank you.
Okay, thank you. So before I go to the floor again, I'll take one more pre-prepared question. So again, from your research alliance, which we understand from your presentation that there is a lot of activities, in terms of not just use cases identification, but in terms of also trying to, have some sort of a validation of some of these use cases. So I would want to check is there any approaches you are using to validate or test 6G technology and prototype? Are there any test beds or experimental facilities that your alliance is utilizing for this purpose? So why don't I start from left to right? So
within SNS projects, we have many POCs being planned, proof of concepts. Test beds, I would say we haven't seen that yet. So to me, a test bed is something more broader where you can try out the fuller range of 6G functionality. We don't yet know what the 6G functionality is, but with a proof of concept, we take individual technology components and we demonstrate them that they work, right? So sensing, for instance, is one AI. So there will be several of those popping up. Later this year, there will be some. I think primarily next year, we will see several large projects being finalized, and they would come with sort of a final POC to show off their work. So it's coming next year, I would say.
Kidong, please.
Thank you. So we have one working group that has some mission statement about the test bed and POC. But recently, I think maybe today, what I can share is something about sensing aspect that is, but it's not really driven by our member company, but with the help of some government sector member. So that's something I can share for now, but I think it's coming more. So yeah, have some more details.
Xiaofeng, please.
Okay, thank you. And I think in our PPT, we already show one page and for the test from the IMT 2030 working group, and we can see we have made some initial experience for AI and also for sensing, and also think that terahertz also included. I think it's quite initial concept level justification, and maybe maybe in the next 2 or 3 years we will also perform some systematic test based on the pre-commercial product, yeah, and then make the 6G technology more mature and then ready for the market.
Yeah. Dr. Namsuk.
So in Korea, we are planning to have pre-6G vision passed in 2026, and also 60 Vision Fest at I mean, the year 2028. So as one of the project in the 60 I mean mega commercialization mega program, we are planning to have a testbed project from next year for the period of during the period of I guess 5 years.
Okay, thank you. Dr. Satoshi, please.
Yeah, thank you. Well, as a matter of fact, we haven't yet talked about 6G testbed inside of Japan, but well, we have a 5G testbed, which is now well, provided by NICT, which is a National Institute of Japan, so that we may be able to think about to upgrade 5G testbed to 6G that may be utilized by multiple operators, vendors, and or vertical industries.
Thank you. Okay, so let me go to the floor again. So Zukang, please. Zukang from Samsung. Oh, sorry, Juho. I didn't have enough coffee.
Thank you. I'm Juho from Samsung. I'm a little bit feeling unhappy about being confused between me and Zukang. I think I look much better than you. Okay, I have a specific question about sensing. Okay, many people are talking about detection of unconnected objects. I think that's very good definition from Gustav. But then, of course, that's very interesting. If we can utilize our radio signals for detecting unconnected objects, it is technically very interesting. And it may be helpful for keeping our society safer, in a sense. But then, main question is about how to monetize such detection of unconnected objects. Basically, who pays money for such operation? If operators are using their license band for such sensing operation, would operators will be really happy? I mean, they are supposed to have spent much money to buy spectrum, right, on license band. Then is it really meaningful, economically viable to provide such operation with license band?
Okay, so basically the question is what's the thinking in terms of making money out of the sensing, right?
Yes.
I mean, we had this same question for private networks, right? Have we answered that? But for the fun, like, let's go.
Yeah, so I think exposure of these new capabilities from the network will be very important in 6G. So we talk about this more than beyond communication services like sensing, compute, AI. Positioning is also a beyond communication service that we already see in 5G. I think the right way there is to expose it as a standardized API. Doesn't need to be standardized in 3GPP. I mean, there are other organizations that standardize this. And then it should be picked up by an ASP, an application service provider, that would pay for this service. So it could be, for instance, a car manufacturer that wants to enhance the safety of cars, pays for this service to the operator to access a certain API for sensing. I think that's one foreseeable future. And so, of course, this monetization will be important because it is, as you say, spectrum use. But we have the vision of not using that much resources from the communication. We should steal just a little bit of the communication resources to send these spectrum pilots, right? So it should not be a very expensive one, but of course it's an investment that needs to be capitalized. And the answer is API.
Anybody would like to add?
I totally agree with that. And also, it will be very important how to gather the data and also store and deliver the data in the network will be important to consider. Then the data can be exposed to the services. Then based on the data, I mean, the service providers can monetize that.
Okay. Anybody else want to say anything here?
Yes, very important question. But I had a chance to have some offline discussion prior to this one. But it's not easy. But I don't think we are committed to have some answer, but probably some comment. So in the context of ITS on the road, ground vehicle, and some part of the aerial vehicle operations, and also robot operation in, for example, in factory setting, basically where the feasibility is very limited. I think there those aspects are something that we have some value for the stakeholder or whatever. So in that context, we just see some possible potential, but I don't think I have some commitment about my answer. Yeah.
Thank you.
I think there's many discussion in 3BP already and have a differentiated between different use cases for 5G already. I think we should have not get the conclusion yet, so we are stay on the road. I think that we need to discuss more, and I depend on discussion in 3BP, and it's hard for IMT2030 to get a final conclusion. At least we can see the potential for the whole work, and if we identify some really useful use case, and we can follow the commercial logic, and then I think all things will be have a good solution. Yeah.
Okay, so any other questions? Eric, please, Orange.
Thank you. So your last question, Puneet, was about the validation of the use cases via POCs. But I think that even more important than validating the technical aspect of the feasibility of the use case is to validate their interest from the customer perspective. Because if there is interest, if there is no interest, if the use case doesn't answer to any need, then they will not be adopted, and then we will have no business. So my question to you, and I would like to get the perspective from all the panelists, is are you doing something in your respective alliances to get feedback from the future users about their interest for the use case, and particularly from the customer's perspective? Because fortunately, we have representatives from different vertical sectors in 3GPP that can provide the voice of those particular customers. But when it comes to the mass market customers, we don't have representatives. Thank you.
So basically what you're asking is, are they doing any sort of surveys, or because?
Yeah, exactly. Surveys or interactions. I know the answer for Europe, obviously, but not for the other regions.
Okay. So maybe then we start from the,
Okay.
Satoshi.
Yes. Well, short answer is yes and no, actually. Well, it depends on the customers as well as the network operators. Well, I'm talking as a representative of KDDI instead of Beyond 5G promotion question from now on. Well, KDDI has certainly has a correlation with the multiple industries and companies, so that we have interactions about seeking new applications, use cases. Recently, we have demonstrated SA as well as a network slicing to online gaming services with Sony company. So that kind of POC activities can be done, and of course we can get some feedback from them.
Would you like to add?
Yeah, I guess in Korea, because we are having pre-60 Vision Fest in 2026, I guess we will invite all the related parties, and I guess we can have the feedback from the customers as well. I'm not sure, how many customers can really, give the feedback on that, but at least the many parties will be invited. So we will try to gather as many as feedback at the time. Thank you.
I think that from China, I think that we have already have many use cases for verticals, just like maybe in IMT2030, we also have some promotion for the vertical industries, and so maybe already only over 20,000 use cases in China, and then there's a really close relationship between vertical industries and also the telecommunication operators, and also from our point of view, just from some information from government, just like MIT, they also promote many actions between the different companies and to promote the whole things. And right now, I think even for 60, we'll also follow the same rule, and I think it will give better feedback in the future. I think.
Yeah, thank you. In the Next G Alliance, we have so in the vertical industry white paper development process, we have invited the industry vertical members, agriculture, entertainment, gaming, ITS, many things around, so that we can try to collect as useful information as possible. So that's how we that's the process we have employed when we try to identify the need from the market, and based on that we try to identify various type of use cases. But still, we have to have some some validity check process in front of us in the context of how feasible, not the technical feasibility, but how suitable those use cases would be in the context of like how we can monetize the core concept that we have in the specific use case.
Yeah, for me it's easier because Eric, your company is leading a work packet in XX2 doing exactly this, so I can point it back to you and say, how is it going? But it's a challenging task because you tend sometimes to get answers like, I want a faster horse. If you ask sort of the stakeholders, the verticals, what they need. You have to understand the problems, but what we're doing is, in a sense, creating new solutions, new markets that are there. As I said in my presentation, there are sort of products that we try to imagine before there even is a factory for them, and even before there is a market for them. And we have to understand: do these make sense? Do they solve any problems? It's a challenging task. But so I think what we should do is to understand the problems at hand that we try to solve. And then whether the solution is right or not, I think time will tell.
Thank you. Any other questions? Chinhui, please.
Thanks, Bonnie. Thanks, panelists, for great sharing. You know, given the name, we are going to build a global 6G view. I believe everybody in this room, we are looking at a inclusive, sustainable, and healthy 6G ecosystem. That's for sure. And I would say global standard underpins the success of ecosystem. So when it comes to standard, you know, looking back to 2018 and 2019, we were working on 5G first release, and we actually took a phased approach. For instance, we decided to implement, specify this EMEB in 15, and then we did some UILC things in 16. And this kind of approach, I would say, really did us some bad in terms of offering 2B and 2C services at the same time with a reasonable cost, which I would say a lot of operators suffered a lot. So my question is, coming to 6G standard, we have 6 scenarios which were specified by ITU. So I would like to hear your original views. Do you believe, you know, in the first place of 6G, of 3BP, we should accommodate all these 6 use scenarios as much as possible in the first release? Thank you.
I think we touched about that a little bit in terms of use case priority, but maybe you want to address from the 6 again.
Yeah, thank you for the question. Well, as I made a presentation during my talk, actually, I don't think we have to prepare everything at the beginning of the first release of 6G, because, well, first of all, we have to see what kind of use cases are very important and monetize for the telecom industries. Otherwise, even if we prepare some new features, the customer don't utilize them, then that is that is going to be in vain, actually. So that is a headache. Well, yeah, you talked about the memory about in 2018-19 days. Well, what we said to industries was that we may be able to prepare everything from the beginning. That's the mislead to the customers actually. So we have to be careful about how to advertise what is 6G. And even now, what kind of things we can prepare to customers using 5G. So if we can correctly announce the capability and the performances to the industry or customers, then where they understand and then they may complain something about the existing networks. And then we may be able to improve or upgrade our systems to other 6G. This is my personal opinion.
Anybody wants to add anything?
Yeah, I think one important part with a new generation is that you provide a new baseline, so you can add in all the new stuff that you developed during the later stages of the previous generations. I mean, look into the deployed systems and the devices. They are mainly release 15, right? So what we had in the first release of 5G is what's out there in the market. We have seen very little of 5G Advanced. I mean, no offense 3GPP, but you do a lot of standards that are not being picked up by the market. But when we do a new generation, we get a new baseline, and this will be then implemented in devices. It will be implemented in networks. So this is the real big benefit, I think, that we can get a new baseline to build on. So that's why I think it's important that this new baseline is as broad as possible, because after that, day 2, 6G, the risk is that we will not see very much market traction on that. It's the day 1 6G that probably will dominate. This is what has happened before, at least. So make the baseline as broad as possible to support many use cases. That's, I think, a key to success.
Anybody else wants to add anything, or we go to next question?
Oh, I think from our PPT, we have already give a clear priority here and say that at least for just like AI communication integration of sensing and communication, also the IoT should be included. Also the baseline is immersive communication. In addition to that, just like ubiquitous connectivity, we are not quite clear what the really application new spectrum or blah blah such things. And also for the another part, just like the multi-connectivity part, I think that we already have a many design from 5G. We are not clear if we should at very initial stage to develop many new such as connectivity things. We can reuse some already designed. Yes.
Okay, we go one more question. Right, who has really good question? Tell me. Except for me. Tune, please.
We heard a lot about support for AI and support for computing, but in my mind, this is going to imply there will be some cloud infrastructure on which computing and the AI support is hosted. But who's going to provide that infrastructure? Will that be network operators? Will that be local edge cloud providers? Will it be global hyperscalers? What do you think? And maybe there's a specific aspect for a specific region where things are pushed in a certain way.
So Kidong, do you want to talk? I mean, the hyperscalers are very active in the Next G Alliance, right?
So I think we are going to have a various type of application and the service that's going to be powered by AI feature. So it's very general, but it really depends on what specific type of AI-enabled service we are going to have. Then that's going to be provided by a particular type of service provider, not the mobile operator, not necessarily a mobile operator. So I think that's the thing I can just mention. And one thing that we can consider is, for example, if we want to have system performance improvement, then I think operator might be the benefit the at the center of the benefit. So in the case, we have two different aspects. One is traditional mobile operator can be the benefit, can be the one who can benefit out of that, and the other third-party service provider that are specific to those type of applications.
Anybody would like to add something?
Yeah. May I?
Yeah, please. Take.
Thank you for your question, and I think really a complex question. I think that our initial thinking is that it's a new opportunity for the operators to provide some new applications and to the maybe to B or maybe to C. I think this is one aspect. Another aspect, maybe we can provide or enhance the AI-related applications for the OTT servers, and it's another aspect. We may not enhance see a lot on that part because we already have some discussions in 5G Advanced already, I think. So in our initial view, and I think that we should first focus on the first part to provide some AI services from the operators first. Thank you.
Yes.
The European view is, of course, that we believe in free competition. So it's up to the best party to offer these services. So I think we should standardize the interfaces to services. And then we will see likely a set of platforms selling and buying services from each other. So the network platform will be one party. There will be cloud platforms. There will be application platforms. These will then form a more complex setup of services and interfacing to each other with APIs, and of course exchanging services according to business relations and having service level agreements. So I think the operators, they have a good position there because, as I mentioned before, they are used to working with regulations, and regulations are probably be stronger in the future, so it will be a free but regulated market. And then the operators can compete with cloud platforms to deliver these services, but it will be a mix for sure. So the cloud platforms are already established, so they will be there in the future as well.
Dr. Satoshi, do you want to say something?
Okay. Well, just one quick comment on the utilization of AI. So there are various ways to utilize AI, right? From the viewpoint of physical layer, network layer, and application layer, and so on. So one of the things we don't have to standardize is that network operation. So from the viewpoint of network operator, we have to avoid network failures, right? So in KDDI case, actually, we have been seeking the possibility to identify what kind of network failure happens, where it happens, and how to deal with this. That kind of things can be dealt with AI technologies. So we're doing that kind of new research by ourselves. And in addition to that, in the future, I think customers want to develop or create their own network, especially for vertical industry may want to have their own dedicated network using KDDI network, for example. Then we allow customers to input their customers' intent or requirement into the our network server through the API, and then, well, our customers may be able to find out what kind of network they can use. Well, that kind of solution may be obtained using AI technologies. That kind of well, solutions would be possible by using AI without standardizations.
So maybe one last question from the audience. So who has not yet spoken? Shutao, yes, you haven't had any questions.
Yes, thanks, Puneet. This is Shutao from Vivo. I think compared with 5G, the sustainability has been one of the demand from ITU perspective for this whole various industry. So I think this sustainability issue hasn't been well discussed in day one when we designed 5G. Even though after 5G deployment, 3PP have designed many features to support this energy saving or like other like sustainability related technology. but I think commercialized it may not be that successful due to the 5G network has been already deployed. So I would like to hear from your region perspective, how we would like to achieve this sustainability goal or demand from technology or from system deployment perspective. Thank you.
So Dr. Nemsok, you want to say basically?
So from sustainability point of view, we are focusing on energy saving based on AI technologies. So in radio access network and also in core network part as well. For now, there is the one issue that we are trying to solve in this country. But, other sustainability issues about reliability or security issues that can also be we are also handling all those issues as well.
Okay. Anybody else want to say? Kidong?
Yes, so in Next Gen Alliance, we have a couple of context about the sustainability. For example, energy efficiency is of course one of them, and also societal sustainability. For example, in the context of digital equity or digital inclusion. So I think energy efficiency is somehow well addressed, but digital equity is something very important in the context of societal high-level societal goal. But the question that we have not yet answered is who is going to pay. So, for example, if we have a fixed wireless access, and also if we have some very nice integration of NTN and TN, then still the thing is who is going to pay the bill. Of course, not me, but so that's something that we keep asking ourselves how we can have some better way forward with some collaboration between government sector and industry members.
So maybe if I just want to pick on the same question and then extend it a little bit, right? So what Shutao is asking is, what is your alliance doing in terms of attaining the goal for sustainability, right? So let me basically twist around the question a little bit and say, have you heard about something called greenwashing, right? So the greenwashing is basically where you provide a misleading informations about the benefit of that product in terms of being energy efficient, right? So is your alliance doing anything in terms of avoiding greenwashing?
Yeah, I mean, that's a serious threat, of course. If we are to be taken seriously, we cannot ever venture into greenwashing. And it's not only in terms of environmental sustainability. We should not greenwash in terms of social sustainability either. So I'm returning again to this triple bottom line of environmental and socio-economical sustainability. We have to look into all these three domains, and we have this tool now that we're looking at in Europe, but I know that it's being looked at least in America as well. This KVI, key value indicator, which is a way of assessing your impact, negative and positive impact on sustainability goals. So this is one tool that we are trying to push now, and hopefully it will enter standardization. And this is primarily a tool to know what you're doing, right? To measure is to know, as some German well-known person said. And this is the tool to avoid greenwashing. I mean, if you actually can establish and assess an impact with KVIs and everyone agrees to that, then you know what you're doing, right? It is no longer greenwashing, right? Mm-hmm. So then that means that you cannot make too broad claims, and it means that you cannot escape in a sense. So, and we should also expect, at least in Europe, that regulation will come into this area as well, and there will probably be requirements on energy consumption, but not only there. I mean, probably on material usage. this is what we expect. And then again, key value indicators can be a way of demonstrating, do you adhere to this regulation or not? And this is a way to avoid greenwashing. So we cannot just talk, we also need to measure.
Okay, maybe I want to close with a question. Like we all talk and we very much favor that we're going to have a one unified global 6G standard, right? That's an goal which we all basically very much want to achieve. So what I'm trying to want to ask you all here is basically what strategies you are employing to avoid fragmentation of 6G standards and technology. Are they, I mean, one way is you don't see that happening. You know, you can, that's an right answer, right? But I mean, obviously, with all geopolitics and things, this has been one of the concerns, like whether 6G stays a global unified standard. So, from your region perspective, you know, are you concerned about this? If so, then what strategies you're employing? So, I'll start with you, Dr. Satoshi.
Well, we haven't yet seen a particular concern about that one, because we believe that everyone prefer to have a single standard, right? So I don't believe that we're gonna have multiple standards in towards 6G era. But well, in order to ensure that we certainly avoid multiple standards, we'd better to focus on good standardization bodies like a 3GPP. That's it.
Okay. So
as one of the countries who which actively participated in 3GPP standard until now, we also believe 3GPP as one standardization group for 6G. So we don't have any concern on this issue. Thank you.
And I think that like in China also, IMT 2030, also the CSSA, we are strongly support the global unified standardization for 6G. And really confident that with close cooperation between different companies, MRPs, also different organizations, we will build a really excellent specification for 6G and also the product.
Kidong.
Yeah, thank you. So I think you are asking something about cellular economy, right?
I'm asking about yes.
Yeah.
I mean,
so that context, I think so far, to the best of my knowledge, and every NGA member company, I believe they prefer to have a single unified global standard. Yeah, that's clear.
Okay.
Yep.
I even had it in my talk that, of course, 3DPP will be there also in the future. We see this is the place to do a global unified standard. But I think 3DPP also needs to be a bit open towards other influences. Maybe there are other interfaces that needs to be picked up. I mean, we see other standardization activities other than 3DPP. And so I don't think 3DPP is threatened in the dominance of communication networks, but there are complementary standards that may need to be picked up on and integrated into 3DPP. AI, for instance, there is now standards on XR interfaces. There are various open interfaces. So I think 3DPP needs to scout a little bit and see what do we include and not be, you know, not do business as usual, but be a bit open-minded and inclusive when it comes to standards. Maybe you need to go broader and further.
So is it fair to say in 3GPP we trust? Right?
Yes.
Okay. So with this, let me thank our esteemed panelists and thank you very much for your time. And we really had an insightful discussion. Thank you.
Thank you.
Maybe if Kevin is here, can we have a picture for somebody? Yes, Kevin, please. Can we have one quick picture? All right. Thank you again.
it's free more time.
Oh, can I still have the mic on, please? Thank you. So next, what we have is basically the social event, which is, I think, the same place where we have the lunch. So we have the generous supporter for this social event. So Apple, Ericsson, Huawei, KPN, Qualcomm, TNO, and Vivo. Thank you very much for sponsoring this event. So the event, I mean, starts it is a cocktail social event. So I think it will be opening at 5:30 and until 6:30. So please utilize this time for socializing. And once again, thank you to all the support. So can you have a round of applause to our supporters for this? Thank you. All right, thank you. We are closed for the day. See you tomorrow.